I think we can start. Good afternoon, good morning, and good evening to everyone. Welcome to the second day of the conference on the macro-financial impacts of climate change and the net zero transition, jointly organized by Banca d'Italia and the Bank of England. Let me start by thanking yesterday's speakers for their insightful presentations and discussions. The first day of the conference has provided a comprehensive background on how climate is evolving, how its effects propagate through the economy, and what are the implications of the decarbonization process. I will now try to summarize some of the key points that have emerged from the presentations in order to set the basis for today's discussion. The risks associated to climate change have been analyzed from different angles. The direct risks are multifaceted, including not only those related to the destruction of physical capital, but also the spread of new diseases, social discontent due to impoverishment of certain areas, the loss of biodiversity, for example, of pollinating species serving agriculture, and related psychological effects. All these risks can be mapped into economic risks. Research using historical data has quantified the impact of climate change on economic activity. Global climatic trends affect the economies through, for example, higher and more volatile local temperatures. Estimates reveal that extremely hot days reduce households' income and firms' output, even in urban areas and in non-agricultural sectors. Temperatures act mainly through reducing labor supply and productivity, particularly in jobs that require spending time outdoors. In the long run, while the share of workers at risk might contract in developing countries, occupations in which exposure is unavoidable cannot and will not disappear. Temperature impacts on workers will remain significant, even in the United States, despite a gradual adaptation to the evolving climate. Natural disasters, as hurricanes or floods, will also become more frequent and intense due to climate change. Differently than extreme temperature events, disasters have catalyzed huge amounts of public resources to support the healthcare system and to rebuild damaged infrastructures. We saw that these events had peculiar and sometimes surprising implications for labor supply and mortality in certain areas. Arresting climate trends starts from a decarbonization of the economy. Substituting fossil fuels with renewables for power generation, for transportation and heating entails electrification of these processes, which requires a huge investment and technological breakthrough. Among the risks related to the transition, a key risk, besides that of stranded assets, is that of low energy security. Wind and solar sources are intermittent and not uniformly distributed within countries. Assessing their long-run availability, taking into account climate change, is challenging. This makes the evaluation of how much energy storage will be needed and how much it will cost as heroic. The net zero transition can have distributional consequences across economies, as single countries' policies are tied to their role in global energy trade. In scenarios in which policies to reduce emissions are implemented, trade of fossil fuels collapses dramatically. Fossil fuel importers have obvious incentives to decarbonize faster than exporters. The most severe implications are suffered by uncompetitive producers, those with high costs of fuel extraction, while more competitive ones will increase their market share and keep producing during the transition period. The financial sector is not immune from the implications of an evolving climate. intermediaries are threatened by natural disasters via their customers and from transition risks through the assets in portfolio. This obviously has repercussions on economic activity, as banks may decide to divert funding away from entire sectors or geographic areas. Survey evidence suggests that large intermediaries have pessimistic expectations about the evolution of temperatures, and while they have serious reputational concerns, active climate risk management is limited at best. Asset prices also contain information on how investors perceive climate risks. We saw that home prices in some coastal areas of the United States embed a premium to compensate for the risk of inundation due to sea level rise. This is not just the case of home prices. Other papers show, for example, that the cost of protection from downside price variations is larger for carbon-intensive securities and increases when public attention to climate does. As information on climate risks and sustainability provided by the market is still incomplete and sometimes incoherent, supervisors can have a role to speed up the process of standardization of information. For example, regulating firm sustainability disclosure. Yesterday's presentations have given a flavor of how far-reaching are the implications of climate change and the net zero transition, and of how much research still needs to be carried out to answer the many existing open questions. Today, we continue to dig into the interaction between climate change and the economy, but from a policy perspective. Next session, session number 3, will explore how policies implemented by different authorities can interact with climate and the economy. The speakers will cover the design of optimal policy instruments, how they affect technology and market neutrality, and what repercussions a delay in climate policy implementation might ignite. Session 4, the last one of the conference, is structured as a panel discussion. Here, policymakers at central banks and international financial institutions sit at the same table with academics to discuss how research findings can fit a real-world policy. The discussion is introduced and moderated by Ignazio Visco, Governor of Banca d'Italia. Session 4 aims at providing elements to form a unified view on climate action across institutions, and at giving insights on how they can interact and exploit synergies to fight climate change. As fiscal, monetary, and international authorities have successfully joined forces to support the world economy during the pandemic, this cooperation should be maintained and reinforced to face the longer-run climate challenge. Let me now leave the floor to Ivan Faiella, who will chair session 3 on climate policies. Ivan, the floor is yours.
Thank you very much, Filippo, and welcome to you all. As Filippo has mentioned, we are moving from the effects and the impacts of climate change to the policy, what we have to do. These policies are sometimes the mitigation policies, and the thing that is going to be explored by Elmar Kriegler, what kind of technology adoption we are imagining, what kind of mitigation policies we want to implement. But then it's also relevant the design, and Caroline Fischer of these policies, and Caroline is going to speak about that. So let's start with the first part of the session. In the next part, we're going to have Lynn Barrage on technology adoption, and Monica Piazzesi that is going to explore a different kind of policy that are it's a bit less analyzed. No? how monetary policy can help in achieving the transition. So let's start with Elmar. Elmar Kriegler is head of the research department Transformation Pathways at the Potsdam Institute for Climate Impact Research and professor for integrated assessment of climate change at the Faculty of Economics and Social Science at the University of Potsdam. Elmar, are you there?
Yes, I'm here. Can you hear me?
Yes, fantastic. So if you can start sharing your screen, and you have 20 minutes for your presentation. Thanks.
So, oops, that's the backup slides. Sorry.
Don't worry.
So can you see my slides in full screen mode?
Yes, fantastic.
Very good. So thanks a lot for inviting me to present at this exciting workshop. And the task I was given was to talk about the economic impact of delays in climate policy and the variation in climate policy tools. So I only skimmed the surface of this very large topic and will focus on the question of delaying climate policies and the challenges this brings for reaching long-term climate targets. So the literature has firmly established that delaying climate policy strongly exacerbates the challenges to keep warming limited to 1.5 to 2 degrees. And there are three elements to this. The first one is that a warming limit implies a finite carbon budget that we need to stay within. So the CO2 emissions of every year accumulated over time, and at some point this accumulation needs to stop, and we need to reach net zero CO2 emissions. That is only one part of the story. There's also the second part, that is that we also need deep reductions in other greenhouse gases, particularly methane. And I'm not talking about the second part of the story, but I just want to mention it here because it is important to keep in mind that reaching net zero CO2 alone is not sufficient to limit warming. We need these very strong reductions in methane as well and other short-lived climate forces. So due to the fact we have this limited carbon budget, a delay in climate policy leading to higher emissions in the near term depletes our budget faster. And so we need to, at some point, reduce more rapidly after a period of weak action, which introduces abrupt shifts in reduction rates, prices, investment flows at the point where we switch from moderate to really very stringent action. So that's the first element, how delaying climate policy exacerbates this challenge to stay below 1.5 to 2 degree warming. The second challenge is that, of course, as we don't put climate policies in place today, or only weak climate policies, we continue the buildup of fossil fuel infrastructure, particularly in those regions that are rapidly developing right now. And that makes it much harder to switch the path later. And we have more committed emissions, we have more fossil fuel assets, leading then increasing the risk of stranded assets if you want to switch abruptly to towards limiting warming to 1.5 and 2 degrees. And the third element here is that excess emissions in the early periods may require deployment of net negative CO2 emissions to return warming to levels that were originally targeted, like if we exceed 1.5 degrees and want to return later to 1.5 degrees by the end of the century, this might require hundreds of billions of tons of net, so-called net negative CO2 emissions, which basically means that the amount of carbon dioxide taken out of the atmosphere by humanity is larger than the residual CO2 emissions put into the atmosphere. These so-called carbon dioxide removal technologies, or CDR, are little researched, come with their own risks, and also their potential of reversing warming is little known. So this is a highly risky strategy that we put ourselves in if we delay climate policy to increase our reliance on these carbon dioxide removal strategies in the long run. Now, let me take a look back and look at the emissions, how they have developed over the past 40 years. And what you can see here is that emissions, these are global carbon dioxide emissions, they have risen with some short interruptions quite significantly, particularly in the last 20 years. Much of that owed to the development of China and the large energy demand this has been has been accompanying this, and large expansion of coal-fired power in China and other emerging economies. So we have emitted cumulatively about 1,000 gigatons CO2 between 1992 and 2020 in these 30 years. And I take the year 1992 as a starting point here because that is the year where the Earth Summit in Rio took place and where the United Framework Convention on Climate Change was agreed by the vast majority of countries, and it's Article 2 stating the goal, the overarching goal of the convention to avoid dangerous anthropogenic interference with the climate system is still the basis for climate policy today. So since then, since this was agreed, we emitted almost 1,000 gigatons of CO2. Now, if you compare this with the remaining carbon budgets we have now, starting in 2020, and to limit warming to 1.5 degrees with a 50% likelihood, you can see it's between 400 to 500 gigatons CO2, depending on the likelihood. This is a median estimate. There's large uncertainty to it. So that's almost only half of what we emitted over the past 30 years. And so looking forward, what our options are, we need to reduce rapidly, steeply, dramatically down to net zero. And you can see this with the green trajectory here. That's about 500 gigatons. It's 30 years until net zero. So the past 30 years, we emitted 1,000 gigatons. The next 30 years, we only can emit 500 if we manage. And the picture also immediately makes clear if we delay further and if we stabilize emissions at this level, and that would roughly be the outcome of implementing the current climate plans by countries, the so-called nationally determined contributions, then you can see this becomes all but impossible. And looking back, and that's my last point on this slide, is if we would have acted on the 1.5 degree warming limit at the time the United Nations Framework Convention was agreed upon in 1992, we would have had about 100 years for this transition to net zero. Now we have only 30 years left, and I'm saying this because I would like to make the point that we are already in a situation of delay. We are looking back at 30 years of very weak climate policies, and so we need to grapple with this in the next 30 years to come. Now, the IPCC, in its special report on 1.5 degrees, has put some numbers on this general statement. So what I'm saying now is not qualitatively not so different from what I have said in the stylized graph. So here you can see an assessment of the literature on 1.5 degree pathways. The one funnel I would like to focus on at the moment is the one in blue. So these are pathways that still manage to limit warming to 1.5 degrees with no or limited overshoot. They reach net zero around 2050. And that's compared to 2075 for 2 degrees. Slide is a bit confusing here. It's 2050, but you can also see a larger spread in this net zero year. But importantly, they also reduce emissions dramatically already until 2030, from now above 50 gigatons down to 25 to 30 gigatons CO2 equivalent, including also other greenhouse gases. This is compared with the gray funnel of pathways that delay climate action, and you can see that there are higher emissions until 2030 following the NDCs. So we end up with emission levels of today's level in 2030. And so these pathways then reduce dramatically afterwards, showing the disruptiveness and abruptness in these pathways. But also the IPCC stated clearly this will no longer be sufficient to limit warming to 1.5 degrees without large overshoot, without this large-scale use of these carbon dioxide removal strategies. Now, very quickly, and do this very short, what is the strategy to reach net zero to limit warming to 1.5 degree? Qualitatively, this is not so different between pathways that limit warming to 1.5 and pathways that limit warming to 2 degrees. The difference is the time. We have 20 years less left for 1.5 than for 2 degrees, which makes a lot of a difference. So you can see the three components here of CO2 emissions. In gray, the emissions from fossil fuels and industrial processes, so mostly from the energy sector and then also from the cement industry. In brown, the emissions from the land use sector, so AFOLU is an acronym standing for agriculture, forestry, and other land use. And then there's this yellow component in this particular pathways where carbon dioxide removal is used. So you can see it's used significantly. And if you look at the strategy, it is peaking as quickly as possible. Basically, the model is forced to not reduce before 2020 because that hasn't happened so far. It needs to shift investments from fossils to low carbon and efficiency solutions. Sorry, this is on the slide. This has been to remove the text. And the first phase then after 2020 is particularly to decarbonize the power sector. So this needs to go first. Also coal phased out in other sectors of the economy. And at the same time, the electrification of end users is to be progressed to achieve this steep emissions reduction in this period. When we reach around 2050, where it's a time to achieve net zero CO2, we need to grapple with some decarbonization bottlenecks, for example, for aviation and shipping and heavy industry. So there can be carbon neutral fuels being used here. There can be hydrogen being used here, but also carbon removal from the atmosphere can already be used to substitute or neutralize some of these residual emissions, as happens in these particular pathways. And in the long run, then there's a larger share of these carbon dioxide removal technologies. But most importantly, the major element of this strategy is to reduce emissions, to phase out fossil fuels, and to increase energy efficiency, to electrify the energy sector, and to move to sustainable land use management that can effectively reduce agricultural emissions and also store carbon in the ground or on land rather than in the atmosphere. Now, if you look at the current plans on fossil fuel infrastructure, there are a number of studies that show that already the existing and planned fossil fuel infrastructure, and this is not only coal-fired power plants or fossil fuel-fired power plants, but also other fossil fuel infrastructure in other sectors, for example, refineries and heavy industry installations. Already these existing and planned emissions commit us to about cumulatively 400 to 700 gigatons CO2 if we run them as long as currently these installations are run. So there would be no early retirement, no reduction in utilization rates. Then we are already exhausting the 1.5 degree carbon budget that I showed on the initial slide. So that already tells us about the scope of the challenge and the economic implications the transition will have, because it indicates that without some early retirement, some lower utilization of the existing fossil fuel infrastructure, and without canceling existing plants, particularly in the power sector when it comes to coal-fired power plants, so that's the biggest gap here, without doing this, this 1.5 degree limit will be exceeded. Now, this brings us to this notion of emissions gap you probably have heard about. So there is an emissions gap between what we have currently committed to in terms of plans and existing fossil fuel infrastructure and what we have committed to in the so-called national determined contributions. These are the plans by countries that they submit under the Paris Agreement for 2030, where they state these are our emissions reduction targets, these are our mitigation goals. Sometimes these plans are a bit weak on policy proposals to actually achieve the targets there. So there's also an implementation gap. It's not clear how countries want to achieve their collective commitment. But the second thing is that there's an emission gaps between the outcome of the collective commitment in the NDCs and where we would need to be in 2030 in order to manage this transition to likely below 2 degrees or 1.5 degrees. What you can see here is a study we did 2 years ago where we looked at the dependence of this emissions gap and how to bridge it on both the climate target and the carbon dioxide, the availability of carbon dioxide removal. So in black, you see a typical trajectory that would emerge under the NDCs until 2030. So basically a stabilization of current emissions. This is an improvement over baseline trends without climate policy. You would see emissions continue to rise. So NDCs do make a change, but it's too small of a change in order to get us close to where we would need to be. Then you see in red a cost-effective pathway that would start off in 2020 to reduce rapidly in order to reach in this case, the 2 degree target. And we can do the same exercise if we have more limited carbon dioxide removal availability, which is a safe assumption, which I think is an important assumption to make because of the risk attached to carbon dioxide removal strategies. And you can see that already both the cost-effective pathways reduces emissions more strongly, as well as the abrupt trend break in these black NDC pathway where the strategy switches from only moderate action to rapid action increases as well. And finally, there is this pathway where we try to reach 1.5 degrees, and that goes through net zero at around 2050, as indicated by the IPCC assessment. Without this very limited carbon dioxide removal potential, we find almost no solution here. So the basic message also coming out of the IPCC report is that carbon dioxide removal to a limited extent will be needed to reach 1.5 degrees. Now, how can this gap be bridged, given the fact that it will be so costly and so challenging to really allow us to not reduce emissions until 2030 compared to today's level significantly. And so what we did in this study, we looked into a number of policy packages, mostly regulatory policies, like so some of the on the fossil fuel side, where it was about phasing out fossil fuels, and that's a restriction on new coal and gas powered plants, upscaling of industry CCS as options. But most importantly, and this is written in the last bullet point, the scenarios also assumed a moderate carbon price. Carbon price is critically important for every strategy because it is needed to phase out fossil fuels. So pushing in new technologies is good, but in order to achieve the maximum benefit from this, there needs to be a carbon price to effectively phase out fossil fuels. So you can see the other policies that we assumed, energy efficiency improvements, renewable energy provisions, electric vehicle mandates, and these kind of things. And what we found is that this could indeed reduce emissions by up to 10 gigatons CO2 equivalent in 2030. So bringing us closer to the cost-effective pathway, but at no small effort, because those regulatory policies are stringent and they are rolled out globally. That's the assumption in the scenario, which is, of course, a very heroic assumption. Now, looking at these pathways, you can look at carbon prices, and now coming a bit to the economic impacts of these different trajectories here. You can look at carbon prices in 2050, which is a good proxy of the overall stringency of the abatement effort that you have to leverage via these pricing trajectories. And you can see that the carbon price is a function of the near-term action. So look at the left column where you have action according to the NDCs until 2030, and then trying to reach the target. And you can see that these are significantly higher, particularly if you don't have carbon dioxide removal available to a large degree, than if you would act immediately. And the other thing that is noticeable is, of course, that the more stringent the target, the higher the price. So we easily reach up to prices of about $500 per ton CO2 in 2050. If you look at the investments, same study still, and see what what investments in the power sector look like in these pathways, you can see for the NDCs in black that the reduction of investments into fossil-fired power plants is only very small. So the NDCs are really not making a big change to the fossil fuel sector. They stay away from it. And they make some provisions to increase investments into renewable energies. So this is very different from what you see in a cost-effective pathways, where you would see a strong reduction of investment into fossil fuel power plants, and also a strong increase of investments in low carbon alternatives. So this in-between strategy using the regulatory policies is kind of mediating between these two cases. So you can see there is already a stronger reduction in fossil fuel investments, which is due to the moderate carbon pricing there and other provisions. And then there is also a stronger investment into renewable energy due to these new technology provisions in the package. So strengthening action using mixes of policies is critically important at this point to avoid putting us in a situation in 2030 where 1.5 degrees is basically out of reach. Now, the last element of my presentation is to look at the dimension of these challenges. I already showed a few indicators here. One is the trend break in emissions reduction rates that you saw from the plots. The other one is the shift in investments and how rapidly this would need to change. And so we kind of came up with a categorization of these challenge indicators into these 5 types. Disruptiveness, so really how, or abruptness, I might better say, how rapidly things have to change from, a trend have to change from here to there. The speed of the transition, the overall speed, the scale, deploying a lot of carbon dioxide removal technologies comes with its own risks. For example, using a lot of land for bioenergy comes with its own risk. The distributional impacts and models have been quite weak in this area, but there's increasing work on really looking into the distributional impacts is, of course, critically important. I will not be able to go into this during my presentation. And then, of course, the efficiency of the strategy. If it's too expensive, society will have problems to go through. And you can see this profile of these, or the implementability or risk profile of these various strategies in this radar plot. I think it's maybe a bit complex, 2 minutes before the end of my talk to go through that in detail. But what you can see is that we used various indicators to try to pin down these challenges. Some of them economic related. So there's CO2 price jumps, food price jumps at the bottom, consumption losses. We also looked into stranded assets in the fossil fuel power sector. And the basic message is that if you put in these additional policies, you can lower the risk profile by some extent, but you cannot avoid it completely. And comparing this across the other 2 strategies, these indicators show higher risk levels if you have very limited availability of carbon dioxide removal, and also if you go to 1.5 degrees, which is a very ambitious target at this point. So let me now wrap up with this my presentation. I focused very much my presentation on this study, but I would like to take a step back from that and say, okay, we are now at a quite important moment for climate policy for various reasons. But the importance of the moment is further elevated by the COVID-19 pandemic, because this shock has led to a reduction of emissions, but that's only a temporary reduction, and we are already seeing the rebound, and we are feeling it in prices in the energy sector already. This is, of course, problematic for climate policy when people try to invest again into fossil fuels to ease this current price hike. And it also shows the bifurcation point we have now. If the stimulus packages we put in place to revive our economies, to grapple with the aftermath of the pandemic, is going back to the old economic model and investing in brown and carbon-intensive activities, we will exactly get what I was showing here as problematic, which is only moderate climate action, high emissions for the next decade, locked into fossil fuel infrastructure, and then we will lose the 1.5 degree target. So this is a pivotal moment to really look also in the stimulus packages, how to make sure that the investment, that the opportunity, because there's also an opportunity, these high investments now being leveraged, to invest in green and transitional technologies, and some of them I mentioned during my presentation. I'm wrapping up with two comments. One is that we have done work with scenario work for the NGFS, the Network for Greening the Financial System, and these scenarios, and probably you all know them, are located in such a matrix that was designed by the NGFS. It includes also a delayed transition scenario, which is the one you see in greenish in the plots, where you can see this abrupt change. So that is a scenario that kind of describes this disorderly transition. And I think more work should be done in better teasing out the disorderliness of this scenario, because the models are still not able to fully capture all the repercussions. And finally, I would like to point you to this resource. That's a pilot project on climate change scenario services, which is particularly dedicated to practitioners who are getting into the world of climate change scenarios, but are new to it and would like to look for a resource where they can receive tutorials and also targeted modules, interactive modules on specific insights, for example, like bridging the emissions gap, which I presented just before, and learn and do capacity building in this way. So with these two links, I would like to finish my presentation. Thank you.
Thanks a lot, Elmar, for this rather scary presentation. Let's move to Caroline Fisher and see if there are some suggestions on how to design policy that are up to the scale of the challenge. Caroline Fisher holds a joint appointment as Professor of Environmental Economics at the VU Amsterdam and as Canada 150 researcher holder in climate economics, innovation and policy at the University of Ottawa. Caroline is also a senior fellow with Resource for the Future and with the European Institute of Environmental Economics and with CZ4 Research Network, and member of Environmental Canada Economics and Environmental Policy Research Network. Caroline, you will have 20 minutes to present for your presentation, and then after your presentation, we're going to have a 15-minute session of Q&A. Caroline, over to you.
Okay, thank you. Can you hear me all right?
Well, yep.
Excellent. Good morning from Washington, D.C. and buon pomeriggio a tutti in Italia. Mi dispiace non esserci con voi. Okay, so I'm going to talk about climate policy instrument design with a bit of a focus on industrial decarbonization. So this will be a little bit more from a micro perspective. In terms of climate policies, we have a great amount of agreement among economists that significant, comprehensive carbon pricing is the most cost-effective lever to reduce carbon emissions at the scale and speed that is necessary. That's a quote from the Economist statement on carbon dividends. It's been signed by 28 Nobel laureates, 4 former chairs of the Federal Reserve, and many economists. So we see a great focus on the power of carbon pricing to incentivize decarbonization across, throughout the economy across a wide range of behaviors. In practice, though, we do see that carbon pricing is expanding worldwide. We see more and more jurisdictions picking up carbon pricing. It's somewhat roughly equally split between carbon taxes and emissions trading systems. However, the prices that we see and the coverage that we see are relatively low, certainly compared to the challenge. Nearly 80% of global emissions face a carbon price of zero and arguably negative due to remaining fossil fuel subsidies. And we see that even most systems that price CO2 have rates, prices that are well below common notions of the social cost of carbon. So this is a graph from last year's World Bank Group State and Trends of Carbon Pricing. So we see the different carbon pricing systems. So here's the EU ETS, for example, is relatively large. It's covering a bit less than half of emissions in the jurisdiction. Now prices are actually getting up here to, I put sort of the Biden EPA notional social cost of carbon. I think most people would put a social cost of carbon sort of in this range. So we see most systems have relatively low prices, and also coverage is less than 100%. The other point that I want to make is that pricing systems that do cover industrial sectors are inevitably coupled with preferential treatment for industry. These are with direct or indirect subsidies for industrial sectors. As we just heard, industrial emissions is potentially an important bottleneck for getting to net zero. And I'll just point out that industry represents globally, a quarter of energy use, and they also contribute direct emissions through processes such as chemicals and cement. So this is a very important aspect of global carbon emissions. These sectors are also, large, they're politically powerful, and they're concerned, arguing that they may not be able to pass on carbon costs that are imposed upon them, being both emissions intensive, and so potentially bearing high costs from carbon pricing, and also trade exposed. So this is from a study of the EU sector, sort of flagging the industrial sectors at risk of carbon leakage. So we see sort of the classic ones, like steel, aluminum, metals here, chemicals, etc. Now it's worth pointing out and reminding that carbon pricing has two kinds of impacts on costs. So one is you have the carbon price itself creates an incentive to abate. So if we have, I'm an economist, so here's my marginal cost of abatement. So the firms will abate as long as the incremental costs are less than the carbon price. And so this leads to total abatement costs of these reductions. And basically any policy that is driving reductions is going to have abatement costs. The second component, though, that carbon is unique to carbon pricing is that it imposes a cost on the remaining emissions. So you have to pay for your remaining emissions. So these are embodied carbon costs. You can see here that unless the reductions are very deep, this rectangle of embodied carbon costs, it tends to be much larger than the triangle of abatement costs. So the question is, what to do about these embodied carbon costs. Many systems offer free allocation or rebating to reduce the net cost of embodied carbon. Now, there are a couple of different types of rebating. It's useful to distinguish between sort of unconditional rebating. So this is an allocation given regardless of the behavior of the firm, which then should not distort the incentives of the emissions price. And contrast this to conditional rebating, which is going to, in effect, subsidize the behavior that the rebate is conditioned upon. So the classic examples that we usually speak about is lump sum rebating. So this would be a truly unconditional rebate mechanism generally used to compensate firms for their lost profits. It's also known as grandparenting. It used to be known as grandfathering. This is, for example, how the U.S. distributed emission allowances under the SO2 trading program. Now, important point is that to the extent that firms can pass on some of the embodied carbon costs, much less than 100% rebating is needed. There have been an early study by Larry Goulder et al. From Stanford found that maybe 15% of allowances would be enough to compensate industry for lost profits. There's a more recent study in Martin et al. Finding of EU firms finding 15 to maybe 25% is enough free allocation to compensate. In practice, though, very few allocation systems are truly unconditional. There are typically provisions for new entrants or significant changes in capacity, and they are updated over time. So that leads us to the next most common method of allocation or rebating, which I call output-based rebating. So the idea here is that the revenues from emissions pricing are returned to firms in proportion to their output. And so then in this case, we see that firms with high emissions intensity tend to make net payments, and firms with low emissions intensity actually get net refunds. Sweden used a form of output-based refunding with a tax to reduce NOx emissions in its power sector. California, New Zealand, these are places with emissions trading systems that explicitly use output-based allocation to firms. So they have a benchmark emissions intensity for identified sectors, and these firms' allocations of emission allowances are updated in proportion to their output multiplied by this benchmark. If we think about the EU ETS, it's arguably something in between lump sum and output-based rebating because we have the benchmarking exercises every few years determining allocations, and also there are provisions for large capacity changes. And then a third form of output-based rebating is explicitly emissions intensity targets. So you have a tradable performance standard. So the benchmark is actually the emissions target, and then you implement it with tradable credits. So emitters with higher emissions rates buy credits from sellers with lower emissions rates. This is an explicitly revenue neutral policy. For example, in terms of CO2 emissions, China's ETS in effect features tradable intensity standards. It's not a classic cap and trade system. And similarly in Canada, the federal backstop has an output-based pricing system, which is essentially a set of tradable performance standards. What all of these forms of output-based rebating have in common is that they're combining two price signals. So one is an emissions price that serves to signal abatement, incentivize abatement, and then the rebate, which in proportion to output acts as a production subsidy. So this rebate serves to offset the cost of embodied emissions on average for the sector and will mute the carbon price pass-through. So it's essentially a signal that we don't want abatement to be achieved by reducing output. We want to reduce emissions intensity. An important point then is that absent other market failures, this rebate is distorting. Normally we would want to see carbon costs pass through because other producers of competing products that may be lower carbon don't have a fair and even playing field because the carbon intensive products are not paying their full costs. A consequence of not using conservation or reduced output as a means of reducing emissions is that to meet the same emissions target, then the carbon price must rise. So you need to get more intensity reductions, and the way to signal that is through a higher carbon price. This means you're essentially shifting some of the burden of reductions elsewhere. Now, there are several legitimate reasons why you might want to consider this kind of conditional rebating. And so there are reasons why you may not always want to price embodied carbon fully. And I think the first one that comes to mind is carbon leakage or incomplete regulatory coverage. So if the firms that are facing carbon pricing are competing with close substitutes from firms who are not subject to the same level of regulation, same level of pricing, then muting that price pass-through helps avoid carbon leakage. Another concern is tax interactions. So these are sort of economy-wide concerns that emissions regulation can interact with pre-existing tax distortions in labor and capital markets. So the idea here is that if you pass through all the embodied carbon costs, you tend to raise prices. Higher prices erode the real wage, which further discourages labor supply, which is already distorted by the existence of labor taxes. So in this case, if you're not using the revenue from carbon pricing to lower other distorting taxes, then using it to keep prices from rising can actually lower regulatory costs. Another concern is price distortions, that you may already have imperfect competition or regulation that causes prices to already exceed the marginal social cost. So you have inefficient pricing. There's a nice study by Bornstein and Bushnell looking at electricity pricing in the United States, for example, and in these blue parts of the country, electricity prices are already much higher than what they would calculate as the full social marginal cost, including the cost of emissions. You have distributional concerns. As you saw before, that rectangle is fairly big compared to the triangle, unless reductions are very, very deep. And so that means that rectangle are the costs that you're redistributing in the economy. So the proposal, so here, this is a study with Billy Pizer a couple of years ago, comparing a cap and dividend approach, sort of lump sum return of revenues to households, which tends to be progressive because poor people on average get back much more than they pay out. But you compare that to a tradable performance standard, which does not change energy prices very much. So we were looking at, there's a large amount actually of heterogeneity in energy use, even within deciles. So although on average, most poorer households would be better off with cap and dividends, some of them are significantly worse off. And with the tradable performance standard, you're not changing prices so much, and you're not, so on average, sort of, lower effects, but much smaller, much less variation. Technical change, which I think Lynn will talk about next, is another reason for thinking about these alternative rebate mechanisms. So, we've seen a lot of studies that the level of carbon prices that we would need to induce technical change, especially if there's path dependence, especially if there are spillovers from technical change that the markets aren't pricing, it's really hard to get carbon prices high enough to induce the amount of technical change that would be efficient. So using mechanisms that can ensure market share and ensure investment value can facilitate investments, and these kind of lumpy investments that we need to decarbonize. Macroeconomic uncertainty is an issue. There we have a recent review paper for NBR, sort of looking at the literature on business cycles and carbon pricing, and actually optimal carbon pricing would sort of follow a business cycle. And there's some evidence that intensity standards sort of offer an in-between that allow for some emissions and price adjustment as economic situations evolve. So basically, there are multiple market failures that can add a rationale for rebating. And then I think the probably most prominent one is that when the regulation would otherwise be insufficiently stringent, you may want to deviate from what we would normally think of as the cost-effective policy. So, a broad-based carbon price that is low may be efficient in the sense of equalizing marginal abatement costs and opportunities across sources, but it's not going to be efficient in the sense of reflecting the true social costs. So if rebating can help greater acceptance of better aligned prices, it can improve efficiency. And we certainly see this. This is a study, Gallup poll a couple of years ago in the US, but polls are very similar in the rest of the world. There's a lot more political support for subsidies, for strategies that avoid imposing new taxes or prices. Regulatory standards are also much more popular than carbon pricing. And finally, I'll end with there's some new rebating mechanisms that are emerging that are of interest. So rebates that may be, so you take the revenues from the carbon price and rebate it to incentivize greater investments in abatement. So Norway has a NOx fund for marine vehicle emissions that does this. And we've seen programs in the UK and in British Columbia that condition rebates on intensity reductions. And what's interesting about these intensity-based rebating schemes is that they combine a price on emissions with a subsidy to intensity reduction. So that's essentially increasing the opportunity cost of emissions. And so the same reductions can be achieved with a lower, a visible emissions price. If these intensity-based rebates are also proportional to output, then intensity-based rebating also supports production in a similar way to OBR. But a little caution, if the intensity-based rebate is a share of the firm's own emissions payments, which is what we've seen in the UK climate change agreements and the BC case, then part of the scheme is to subsidize emissions as well, and you don't, and you lose some efficiency there in terms of equalizing the incentives across firms. So I'll end with this summary. Addressing concerns about product price impacts can make room for stronger carbon pricing. We see that intensity-based rebating can amplify incentives for reductions without raising the carbon price if that's a political constraint. Conditional rebating mechanisms, we have to remember, can be distorting, although they can be helpful in a transition, dealing with competitiveness, distributional issues, etc. I think having benchmarks too can focus attention on the technological opportunities and the challenges that are needed for complementary R&D policies. And we have to remember that it's really important that the benchmarks be well designed to avoid introducing yet other distortions. And also remember that rebating is just one of several potential uses of carbon revenues, which could otherwise be available to boost the recovery, to shore up fiscal balance sheets, etc. So thank you very much for your attention.
Thanks, Caroline. Thanks a lot for your presentation. Then I open the floor here in presence, and also if our colleagues that are connected through WebEx, they do want to put some questions in the chat. I have a nice breaker question. One for Elmar. Elmar, you presented us a chart where you are showing that with BECS technology, bioenergy with CCS, we need to capture as much as 20 gigatons. My question is really technical in a sense. We really have the capacity, according to your experience, to deploy such an intense absorption of greenhouse gas. And the last one is on Caroline, because I think, Caroline, you are treating a very interesting topics, because when we are thinking about carbon pricing, we are usually focusing on social unrest, on social issues, while you are more focusing on, if you want, industry acceptability. And I really would like if you could elaborate a bit on the relation between the two, no? Industry acceptability and social acceptability, also because in the concept of just transition, we have both. We have the impact of carbon pricing on vulnerable households, but we also impact of carbon pricing of the transition on jobs and sectors that are more affected. Thanks.
Yeah, thanks. So maybe I start on the question on carbon dioxide removal. So this particular scenario is certainly unrealistic. Having 20 gigatons of carbon dioxide removal is something that models can do, but that will not, it's very unlikely to happen in the real world. In scenarios that really try to take sustainability concerns, other risks into account, the amount of carbon dioxide removal is limited to a few gigatons after 2050 per year. And also, very importantly, carbon dioxide removal is much more than just bioenergy with CCS. The models have overemphasized this technology. It was hotly debated also in the fifth assessment report, but now there's recognition that we have a number of options in the land use sector, starting from things like peatland restoration to enhancing soil carbon, agroforestry, and these kind of measures. There's potential there. There are ideas to chemically remove CO2 from the air with direct air capture. Some startups have been in the news lately here also, and also use the CO2 that is removed not only for sequestering and storing, but they could also be recombined with green hydrogen to produce synthetic fuels. And so you can already see how the idea of a carbon economy comes up here, which is much broader than just bioenergy with CCS and sequestering. So limited amount of CDR and also multiple options here and not relying on only one option.
Thanks. Caroline?
Yes, so I like your question about sort of the different types of political acceptability for carbon pricing. As economists, we tend to, really push for economic incentives as being efficient, and they're efficient because, you could, in theory, redistribute the benefits and make everyone better off. But that's only in theory. In practice, it's really difficult to design systems to do that. And so we see, so let's draw a distinction, but as you said, with the household acceptability, where so households are affected by increases in energy prices and gasoline or electricity prices. There are certainly mechanisms in place. So, for example, in British Columbia, part of the revenues were given back to households. The Canadian federal backstop is similar. And most households are better off, make money out of that system than not. But I think there are important problems in communicating that because many people. So I have some colleagues at the University of British Columbia that found when people were informed of how much they were actually paying and getting back, they actually believed less that they were really, being compensated. So there are important perceptions about that, and I think also important heterogeneity. So like the Gilets jaunes in France, you have fuel price hikes, even to pay for greener cars, but the price hikes hit people more in certain areas of the car-dependent areas of the country than they might in the cities, and so you may have it's very difficult to actually redirect the revenues to compensate folks in a way that doesn't interfere with the incentives to households. So that is a challenge, but again, we need to do a better job of communicating that by not using these sort of incentive-based policies, getting the prices right by implicitly subsidizing fossil fuels, then as a society we need to spend a lot more to subsidize technologies and to decarbonize the economy, which is going to weigh more heavily on public coffers and on citizens in other ways. So that message is a lot more complicated to get through, but it's an important one. I think contrasting with industry, they're going to be very knowledgeable about the effects of carbon pricing and are much more concerned about competitiveness because if they're exporting and competing on global markets, they rightly are less willing to undertake costs if their competitors are not facing similar costs. And so this is why we see a transition to border carbon adjustment in the EU as part of the EU Green Deal. But even within that, though, there's a great reluctance in industry to give up on free allocations. They want both. But the industry, in most places, there's a greater acceptance of carbon pricing because they would prefer more cost-effective methods of regulation, but they want it in ways that don't harm them vis-a-vis international competitors, which gets us back to the ultimate problem of climate change, is that this is a global, emissions reductions are a global public good, and there are great incentives to free ride, and we do not see enough action around the world.
Thanks, Caroline. I agree that the message should be clear, that the transition is going to be costly. We have a question from you from the web chat, from the Zentis. The question is, in consideration of uncertainty of the climate change risk multidimensional effects, could you elaborate if you think it's a good idea to set a tax for the negative externalities in both companies and consumers, maybe replacing in part income tax, in order to allocate resources in a neutral way? This neutrality could provide price incentives without imposed restrictions in the technology, production, and social adaptation? Question mark. It's quite a question. So that's over to you, Caroline.
Yeah, that's often a strong recommendation of how, like, good practices for implementing carbon pricing. So using part of the revenues to reduce other more distorting taxes in the economy. So the tagline is tax bad's not good. So tax carbon and reduce taxes on income, on productive inputs to the economy. So that that will certainly reduce the tax interactions that I mentioned, and so having part of the revenues devoted to that, and then other parts devoted to addressing the distributional and justice issues, and then also the technology investments, technology R&D investments that need to be supported.
We have another question for you, Caroline, and that's more specific and it's rather interesting, but it's again difficult to answer. From Eller Thorsten, can a well-designed rebating system alleviate the need for carbon border adjustment? Part of the reason for carbon border adjustment mechanism in the EU is to replace current exemptions for given sector. Would there be a design for rebates that could at least alleviate the need for carbon border adjustment while still preserving external competitiveness?
Thanks for that question. And you know, I think that has been the approach of the EU for a long time. And I think you know, as long, you know, when carbon prices and you know, the reductions targets are relatively modest, rebating is a reasonable substitute for border carbon adjustment. In fact, and I think that is why most you know, most countries, most jurisdictions that have carbon pricing on industry have been using rebating. Also because it avoids some of the potential trade frictions that setting up border carbon adjustments do. But we do see now, I think a last slide that I had was talking about sort of the limits and limitations to rebating, that as you get more ambitious, then you know, the distortions from the rebating, you know, for example, in the EU, if we're trying to get to net zero, then there aren't any allowances to allocate freely anymore. So, so as the standards get very stringent, it's hard to use rebating. You would have to go into fairly flagrant subsidies, which also are, you know, have trade legality issues. So I think we see the transition towards border carbon adjustments as ambitions get stronger, and you know, as a relatively more efficient policy in terms of, you know, if the goal is really to have you know, more complete pricing of embodied carbon and sending the right price signals through the economy.
Thanks, Caroline. We have a question now for Elmar from Enrico.
Elmar, thank you for your presentation. You show us a very comprehensive and nice list of policy intervention, and I would like you to elaborate about, given your expertise, if you have any insight on which policy mix of those interventions could be more preferable, considering that any policy initiative has trade-offs in terms of climate change goals and GDP and other macroeconomic effects. Thank you.
Thank you. Great question, and also a very difficult one. So first, I think policy coordination is very important. We often have the situation that there are individual sector policies put in place by different ministries, and those don't really go well together. And then they're mixed with cross-sectoral policies like carbon pricing or so, and often coordination is lacking. So policy coordination is critical. In terms of how to embed or combine regulatory policies with carbon pricing, I think a good starting point is to look what additional externalities we have in the markets. Definitely, when we think of the transport sector or the building sector, it's very clear. There are spillover externalities, there are network externalities, there's asymmetric information involved. So looking for targeted policies to address these additional externalities that carbon pricing cannot address would be useful. So that is, I would say, on the one hand, policies to support innovation. Caroline pointed this out, that carbon pricing is not doing well in inducing innovation. So that there will be targeted support for public-private partnerships and in producing new technologies, new ideas. Then I think pull policies that bring things to the market, like electric mobility mandates or subsidies, renewable energy. We have seen the effect of this. So I think these are useful combinations. I would also like to point out that there is a connection to the land sector here, which is an important one. First, I mentioned that it's not only about reducing CO2, but also about reducing methane, and a lot of methane is coming from the agricultural sector, particularly from livestock. The second element is that the land sector can also store CO2 in soils and plants. So here, I think a lot of incentive schemes would be useful. And when we think of a market for emissions reductions and also a market for carbon dioxide removal, in the models, it's all mixed together into one market. And I think for getting these started, it's wise to separate the two and really have a separate market on carbon dioxide removal and develop this carefully, including regulation. Thanks.
Thanks a lot, Elmar. So we close this first part of the session. We're really grateful for your presentations and contribution and for the discussion. And I just quickly move. We are a bit late. Sorry for the next presenter to the next part of the presentation. We were going to have Lint Barrage presenting a paper on technology growth and climate policies, and Monica Piazzesi later on climate change and monetary policy. Let's start with Lint. Lint is assistant professor of economics at UC Santa Barbara and faculty research fellows of the NBAR. Lint, over to you.
Excellent. Thank you so much. Can you hear me okay? Wonderful. All right. So in my remarks today, I would like to make the following key points. First, that technological progress is essential to addressing climate change in a growing global economy. Second, that at present, incentives for this innovation are grossly insufficient. In fact, we've seen during the past decade declines in many measures of green innovation in many countries. Ensuring appropriate incentives for innovation and mitigation requires not only a price on carbon emissions, but also direct fiscal support for innovation. And many models have found that providing such appropriately structured incentives can yield enormous economic benefits. I'd then like to close with a case study on the importance of considering implications for innovation incentives in both changes in energy markets and climate policy through the lens of the shale gas revolution in the United States. So I think it goes almost without saying that energy is essential for economic development. We know that there's a strong positive association between energy demand per capita and GDP per capita, shown here on the right. Now, globally, energy access remains a major challenge. By some estimates, about 1 in 10 people still lacks access to electricity. And importantly, almost half the world's population lacks access to reliable sources of energy. And we know that reliability is important for productivity and economic growth. We see this obviously in the short run right now with countries that have suffered industrial output losses due to electricity outages. But we also see it in the long run, even in countries that are used to having shortages, they'll still contribute to lower levels of productivity and serve as an impediment to growth. Another important thing to remember about the energy challenge we face in the next 30 years is that global energy demand is predicted to increase substantially by about 80% by mid-century, according to some estimates. And 100% of this demand increase is generally projected to come from emerging economies. Now, against the backdrop of this challenge, an unfortunate reality is that with current technologies, fossil fuels are generally still the cheapest source of reliable power available. Of course, that's not the case everywhere in every setting, but I think it's important to note that some of the numbers we sometimes hear about solar and wind costs having come down, they often disregard the fact that those sources of energy are intermittent. And when we calculate the levelized cost of providing, say, electricity, excuse me, from fossil or renewable intermittent sources, adding the cost of backing up intermittent sources from batteries or natural gas, for example, we often see, as shown here in this graph for the United States, that existing coal or gas power plants are still cheaper than solar backup with wind, with gas, or wind backup with batteries or gas. Now, the need for technological progress is also apparent when we dig under the surface of some of the scenarios of emissions reductions that are often mentioned as a policy aspiration. So, for example, the path to net zero by 2050, we already saw in Elmar's presentation the immense changes that are required for these scenarios. But we can also see specific predictions of some of the large-scale deployment of relatively novel technologies that will be required. So here are some estimates by BP for, in blue, the transition to net zero by 2050. And we see, for example, that the share of renewables is predicted to have to increase from about 5% of primary energy to 60% over the course of only 30 years. We also see that what may be required is rapid electrification of transportation and other sectors, so that the share of electricity in final consumption will increase from about 25 to almost 60%. Novel technologies such as hydrogen and carbon capture and storage will also have to play a significant role and be widely deployed in some of these scenarios. Now, to put this in historical context, we've historically seen that energy transitions progress on a slower pace. So, for example, for coal displacing biomass, it took 50 years from coal to go from 5% of global energy supply to 40%. It took 50 years for oil to go from 5% to only 30%. And again, one of the potential benchmarks going ahead may be to take renewables from 5 to 60% in only 30 years, highlighting the big challenge that we face and the progress in technologies that will be needed in order to facilitate this transition. Now, unfortunately, these policy aspirations stack up quite poorly compared to the current market reality. So one thing that we've seen in the data is that during the past decade, green innovation has actually been declining in many areas and measures. So on this graph, we have 4 measures of green electricity innovation for the U.S. Patent Office, patent filings at the U.S. Patent Office, including renewable over total patents, renewable over fossil fuel electric patents, green, that's renewable plus nuclear plus biofuel over total patents, and green over fossil fuel electric patents. And all of these measures show a similar trajectory, that there had been a steady increase in green innovation, but around 2009, 2010, a decline started that continued throughout the subsequent decade. I should say on this graph, these are ratios, but we also find that the level of green electricity patenting has declined over this time period. It's not just the United States. We see similar patterns in other countries. So here in this graph, we have the ratio of renewable over fossil fuel electric patents, and we see declines during the past decade in Japan, in Germany, in the United Kingdom, and many other important innovation markets. Now, there's many potential contributing factors driving this change in the market, but one likely key contributor is the fact that fossil fuels have been cheaper for much of the past decade. So we see on this graph the ratio of green over fossil fuel electric patents filed at the U.S. Patent Office against a 2-year lag measure of natural gas price index in the United States. And what's been true, not just during the past 10 years, but also before, is that cheaper natural gas is generally associated with subsequent reductions in green innovation and vice versa. We see this not only from eyeballing the graph, but many studies have shown, looking both at micro evidence of patenting at firms and at macro evidence looked through the lens of just structural macro models, that cheaper fossil fuels are generally associated with reductions in green electricity innovation, reductions in energy efficiency innovation, reductions in clean automotive technology patenting, and a host of relevant innovation measures. We see here also the graph on the right is from a recent paper by Hustler et al. Looking at the or demonstrating the co-movement between fossil fuel price indices in red and changes in the rate of progress in energy efficiency technologies, which again we see cheaper fossil fuels generally mean reductions in the acceleration of efficiency in energy uses in GDP. Now, of course, to be more precise, the concern is not that fossil fuels are cheap per se, but that they fail to reflect the social cost of carbon emissions. Carolyn was already discussing this in her presentation. But some estimates by the IMF from a couple of years ago suggest that the average global price on carbon right now is as low as $2 per ton CO2. Contrast that with standard estimates of the social cost of carbon emissions around 40, 50 to 100 plus by some estimates dollars. This is also in line with what would be needed as a starting point for reaching the Paris Agreement temperature goals. So the first reason that currently market incentives for green innovation are insufficient is because carbon prices are simply too low. A second likely culprit is low levels of direct fiscal support for innovation activities. It's important to note that green innovation really suffers from a double externality because on the one hand, the benefits of emissions reductions are not priced by the market. But it's also generally true that the social benefits from innovation exceed their private returns. And some recent models of directed technical change that account carefully for the way that innovation process builds on itself have further found that this innovation externality is larger for green technologies than fossil fuel energy technologies, as we want the future size of the green energy market to be larger than it is today. All of which is to say that ensuring appropriate incentives require not only a price on carbon, but also direct subsidization of green R&D activities. Now, of course, such subsidies exist, and it's slightly more challenging to judge them from an efficiency perspective, but here's a couple of figures we can mull over, so to speak. So from 2009 through 2018, the US Department of Energy's average annual funding for all types of energy R&D, including fossil, was about $4.8 billion. To put this in perspective, over the same time period, on average, US households spent about $7.3 billion on Halloween candy and costumes every year. Now, of course, this says nothing about efficiency. And constructing an estimate of the efficient green subsidy requires a quantitative model of the innovation process, which there's a lot of question marks in how to do that. But some studies have put forth such models, and they generally find that the optimal green R&D subsidy should be right now on the order of about 90 to 100%. What we do see in the data tends to be lower than this. So the most recent year of high quality US National Science Foundation data suggests that renewable energy effective average R&D subsidy was only about 14%. There's some other estimates that put the overall clean energy subsidy slightly higher, but generally below, again, what would be required to internalize the externality, which is a much higher subsidy. Now, it's important to know, I think we all intuitively know this, but it doesn't hurt to remind ourselves of the numbers, that appropriately structured fiscal support or taxation of carbon and energy could yield large economic benefits. That's true not only globally, but also domestically, certainly for large economies such as the United States. So here's just some estimates from my own work. There's many others in the literature, suggesting that optimized carbon and energy taxation could yield welfare gains at the global level of $24 to $40 trillion, and even strictly domestic benefits in the United States from $170 to $1.8 trillion. Now, this is a wide range, and some of that range comes from differences in assumptions over what the fiscal scenarios will be that governments face going forward. Because both the revenue benefits of carbon pricing and also the fiscal benefits of mitigating climate change, which will reduce the fiscal costs of climate change itself, such as natural disaster aid, healthcare costs, some of which Tatiana discussed yesterday, depend on the fiscal scenario. But certainly in a fiscally constrained economy, we would expect the larger end of the benefits of carbon pricing. Also, again, studies have found that integrating carbon taxation with appropriate subsidies for R&D activities substantially increases the welfare gains from climate policy, on the order of 1.5–2% of a balanced growth equivalent consumption increase, according to some recent estimates. So I want to close with a mini case study, again highlighting the importance of thinking about innovation incentives in energy markets and climate policy design by discussing the shale gas revolution in the United States. So over the past decade, there's been a dramatic increase in the United States in natural gas production from shale deposits, and that's thanks through breakthrough advancements in the combination of horizontal drilling and hydraulic fracking technologies. And as a result of the strong increase in supply, we've also seen an increase in the consumption of natural gas in the United States, including its role in electricity generation. So on this graph, we have the respective shares in US electricity generation of coal in red and of natural gas in green. And we see that during the past decade, natural gas has surpassed coal as the dominant fuel in US electricity generation. Now, from a climate perspective, this is significant in part because natural gas emits around 40% less carbon dioxide per BTU of energy than does coal. So along with this rise in natural gas, we've seen a dramatic decline in the CO2 emissions intensity of US electricity generation, depicted here in red. We've also seen a decline in CO2 emissions levels from US electricity generation, depicted in green. Studies have documented this again also more carefully with careful empirical studies at the electricity generator level. And I should say the literature has also documented that the shale boom has led to increases in incomes and wages in the United States. Now, that all being said, these short-run benefits, we have to remember what we saw a few slides ago about the strong association between natural gas prices and green innovation. That cheaper natural gas we would generally expect to lead to a reduction in green innovation, as we have seen in the data. And so together with my co-authors, we construct a quantitative model of the US economy, including energy innovation, that replicates the implied increase in the share of scientific activity focusing on fossil fuel electricity technologies. So the graph on the right, we have time on the x-axis, and the green line is the predicted share of researchers working in fossil fuel technologies before the boom, and the blue line is the share of researchers working in fossil fuel technologies after the shale boom, absent further policy intervention. And the model predicts that the shale boom would delay the transition to a green economy by shifting innovation away from green toward fossil fuels. So as a result, our model suggests that the shale boom has mixed effects on the climate. On the one hand, as we already saw, so on this graph is the percent change in each variable as a result of the boom over time. For emissions depicted on blue, we predict, yes, a decline in emissions in the short run, but absent further policy intervention, an increase in emissions in the long run. And again, this is because the shale boom shifted innovation away from green toward fossil, and by improving fossil fuel generation technologies, made them more attractive than they would have been. By delaying innovation in green, made them more backwards than they would have been at this point in time, thus creating an increase in emissions over time. The initial increase in GDP due to the shale boom is also, in the long run, offset by decreases in GDP arising from the fact that increased emissions lead to increased climate damages, which will eventually decrease GDP, again, holding all else constant. So the optimal policy response to this, once again, would consist of a carbon price that is rising over time and a high level of green innovation subsidies, shown here in the panel on the left. And I should say these innovation subsidies are slightly smaller in magnitude, 30 to 40%, than the previous figure I mentioned. This is because in this model we have an America First planner, so to speak, who doesn't consider the rest of the world. Importantly, we also find that the optimal policy response to the shale boom is to increase subsidization of green innovation to counteract the side effect in technology markets. With these policy responses in hand, the shale boom could be strictly beneficial by decreasing the cost of climate mitigation and without having this detrimental effect on green technologies. So to summarize, again, the main points I wish to highlight are first, again, the importance of innovation in addressing climate change and allowing for growth in emerging markets. Second, the fact that at current market situation, incentives for this critically needed innovation remain grossly insufficient due to both the lack of a carbon price and limited fiscal support, and that providing these incentives could yield enormous economic benefits. Finally, we see through the example of the US shale boom that while in the short run emissions may have declined and GDP may have gone up, without appropriate policy intervention in the long run, there is a risk of emissions increasing and GDP decreasing, again, highlighting the importance of thinking about innovation. Thank you.
Thanks a lot, Linta. Very interesting presentation. We go to the next speaker. She is Monica Piazzesi. Monica is John Kenney Professor of Economics at Stanford University and BR Associate as EPR Senior Fellow and CPR Research Fellow. She's going to talk about climate change and monetary policy. We are central banks, or more than interested to hear her. Monica, are you online?
Yes, thank you very much.
Fantastic.
Can you hear me?
Yeah. Over to you.
You see my slides well?
Not yet, but maybe it's just... Okay, yeah, we see it. Everything's fine.
I'm going to talk about climate change and monetary policy, and I'm going to draw on joint work with Melina Papuzzi, who's at the ECB, and my colleague Martin Schneider. So interest rates have been low for a while. So we're in a low interest rate environment, and in this environment, the main tool for monetary policy has been unconventional monetary policy. Central banks have been buying assets. Initially, they bought government bonds. Then they started buying mortgage-backed securities, other asset-backed securities, and most recently, central banks have started buying corporate bonds. The goal, of course, is to lower firms' cost of capital, stimulate investment. But the question remains, which corporate bonds should central banks buy? And so the conventional view on this is that monetary policy should aim for market neutrality. The reason is that central banks don't have a mandate to favor particular firms. So they don't have a mandate really to do green investment. And so they want to stay market neutral. And so what they do in practice is purchase bonds proportional to the amount of bonds outstanding. So this is a simple formula that central banks use in order to stay market neutral. And so in this work, what we're trying to do is understand what are market neutral asset purchases. So if I had to advise the central bank on how to be neutral, what would I recommend? And also, what is the current ECB portfolio look like? Is that neutral? And then we can also ask the question that Caroline and Lind asked, essentially, what's optimal? What is an optimal policy, especially in a world where you have both climate externalities and financial frictions? And so the empirical part that I'm going to show you is we're measuring ECB holdings of individual bonds that are in the ECB portfolio. We measure outstanding bonds of firms in the euro area, and we measure emissions by sector. And we benchmark these holdings to the market portfolio of firm values. So think about a sector and think about all the firms within the sector. And there we want to measure what is the market value of equity of the firms in the sector plus their debt. That would correspond to a measure of sectoral capital shares. So we want to know, how does the ECB portfolio compare to the market portfolio? And what it turns out is that the ECB portfolio, the current ECB corporate bond portfolio, looks like sector shares of emissions. It does not look like the market portfolio. And so what happens is that the ECB overweighs sturdy industries relative to the market portfolio. You may ask, why is that? Why does the ECB assemble a portfolio that looks like the sector shares of emissions? The reason is that the way the ECB implements its notion of market neutrality is it buys proportional to the amount of bonds outstanding, and it just happens to be the case that dirty sectors issue relatively more bonds. They have more tangible assets, and so they can issue more bonds, and so that's what they do, and then the ECB buys these bonds. We can still ask the question, are dirty asset purchases market neutral? Are they somehow optimal, or should they be greener? And so for that, you need a framework. And so we've been working hard on coming up with a framework to think about market neutrality and optimality of asset purchases by central banks. And so this is a growth model with heterogeneous firms that features climate externalities and financial frictions, where firms are heterogeneous because they differ by how risky they are and their emission intensity. And so then asset purchases in this framework work through liquidity and risk premia. There's a liquidity effect because by announcing that the ECB will buy bonds of a firm, it will lower liquidity premia on firms' bonds. And that benefits firms that are highly bond levered more. There's also a risk effect, which is that a purchase program creates more safe central bank debt, or safe government debt, and thereby it lowers risk exposures of private intermediaries. That lowers risk premia on many, many assets, not just the assets that the ECB is buying directly, but it's benefiting many assets. In particular, it benefits risky firms more. And so this is a general equilibrium effect that is really important and is the key transmission mechanism of unconventional monetary policy. And so within this setup, we can ask, what is a market neutral policy? And so the natural way to define market neutrality will be to say firms should have the same relative cost of capital before and after the policy. So the central bank does not benefit one firm in terms of its cost of capital relative to other firms. So in other words, the policy only has macro effects. It does not distort the market portfolio. And what we show in the setup is that a market neutral policy essentially does not exist. It only exists under very special assumptions on the model that are not supported by the data. In particular, the current ECB portfolio is definitely not true neutral. It favors dirty firms. These firms are both bond levered and risky. What's optimal? And so this goes back to what Lind and Carolyn already mentioned. What would the planner do in the model? The planner would design a carbon tax and also an asset purchase program, which is addressing financial frictions. So the asset purchase program would not look at climate externalities. Instead, it would focus financial frictions. And so it would not be neutral because it would favor risky firms where the financial frictions show up the most. And so it would, these purchases would not look neutral. They would favor risky firms, but it would need a carbon tax in place. What if there is no carbon tax, or a carbon tax, as Lind mentioned, that is not sufficient? Then it's beneficial to favor green firms. So let me talk about the literature. There is a big literature that looks at price impacts of unconventional monetary policy. Most recently, these papers have looked at the price impact of corporate bond purchases. There's a number of papers that think about the economic mechanisms of through which unconventional monetary policy works. So here we want to understand what happens in the cross section for different firms. And so basically, as soon as you start thinking about the cross section, it's related to thinking about misallocation of capital in different firms. And so there's recent work that thinks about how does monetary policy affect the misallocation of capital in the economy. Most of this work focuses on conventional monetary policy. And so here, when you think about green asset purchases, this is thinking about misallocation from the point of view of unconventional monetary policy. Naturally, it's also related to integrated assessment models that think about the negative impact of the quality of the environment on future TFP. So as the environment worsens, how will that negatively affect TFP? And then you have an exploding literature recently that thinks about climate finance. Lots of work documenting that firms that pollute have to pay a higher cost of capital, both in bond markets as well as in the stock market. And there's recent work, including at the Bank of Italy, on green monetary policy and thinking about what is the role of monetary policy in this. So let me first show you what the ECB currently does. So this is using data on individual securities holdings of the ECB, so individual bonds that we merged to the ECB centralized security database on the amount of bonds outstanding. And so what's important in this work is to deal with special purpose entities. If you look at the raw data of bonds that the ECB holds, you find that 56% of ECB holdings are firms in the finance sector that issue these bonds. But we know that those bonds are ineligible because the ECB cannot buy bonds of firms in the finance sector. And so what is going on? What the ECB does, it buys bonds from companies like Royal Dutch Shell, which is an oil manufacturer, but the bonds are actually issued by a subsidiary of Royal Dutch Shell, which is Shell International Finance BV, which is a company that officially belongs in the finance sector. And so what we do is we research special purpose entities. You have to do this by hand. You have to research every individual bond and then attribute the bond to the right sector. That reduces bonds in the ECB portfolio issued from the finance sector to 11%. It's hard to get beyond that because there are finance companies that issue bonds for very small companies, and then it's hard to attribute these bonds to the right sectors because these are small companies. So what I'm going to show you is results for the non-financial sectors, but again, we're only missing 11% of the ECB portfolio. And then I'm going to benchmark the ECB portfolio to 3 measures of the market portfolio by sector. The first measure is capital income from Eurostat. The second measure is book assets of companies from Orbis. The third measure is for public companies within the sector. I can measure market value because I have the market value of equity from Orbis. And luckily, the results using the 3 alternative measures look the same. You'll find them on the paper posted on my website. Here today, I'm just going to show you capital income shares. So here's how they look like. On the horizontal axis, you have what is the share of total capital income that each sector has. And on the vertical axis, you see the various sectors: agriculture, automobiles. There's a large manufacturing sector that we split up into subsectors that have very high emissions. This is oil and coke, chemicals, basic metals, and non-metallic minerals. And then there's other manufacturing that you see further down the vertical line. Utilities, transportations, and services. And so what you see is that Europe is an advanced economy, and in all advanced economies, the service sector is the largest sector of the economy. Let's compare that to the ECB portfolio. So this is how the ECB divides its bond portfolio into the various sectors. And so what you see is that the ECB holds a fair amount of bonds issued by the automobile industry, dirty manufacturing, utilities, and transportation, and other manufacturing. And it doesn't hold many bonds issued by the service sector. Let me compare that with emissions of the various sectors. So these are Scope 1 emissions, direct emissions of the various sectors. And so here, now your eye starts comparing the red, which is the market share, with the blue, which is the ECB portfolio, with the gray, which is emissions of the sector. And so what you see is that what the ECB is doing, it's overweighing dirty sectors, dirty manufacturing, utilities, transportation, other manufacturing, and it is underweighing services. Services is a relatively clean sector, and the ECB is not buying many bonds issued by the service sector. And so then you can think about this portfolio and ask, what is the, how can we think about this? Are these asset purchases by the ECB, are they somehow, can they be neutral or can they be optimal? Is this portfolio a good portfolio for the ECB to buy? And so for that, I need the framework. And so the framework is going to be a growth model with a representative household that has preferences over some final consumption goods, so standard preferences. The household inelastically supplies 1 unit of labor. There is a final good that is made from intermediate goods. So there are different sectors in the economy, and there are very many different varieties of goods that are produced within the sector. And so the way we're setting this up is in the standard way of setting up a growth model with different sectors where final output is a Cobb-Douglas aggregate of output in the various sectors, and the various sectoral outputs are a CES aggregate of the individual productions of individual firms within the sector. Then we add firm-specific climate externalities in production. And so the way this is done in integrated assessment models is that you have a measure of the quality of the environment. We call this ADA. And I'm going to call it, for short, I'm going to call it temperature. And so temperature increases with the emissions of the various farms. So you see epsilon here, I, is the emission intensity of firm I at time t. And so if firm I produces little yt at time t, then total emissions of that firm is just epsilon I times yi. And so you aggregate up all the emissions of the various farms, and that increases temperature. So you see these unit root dynamics of temperature. And then they're linear, but then they may affect TFP in production of firm I. So here you see that production uses a standard Cobb-Douglas production function where the capital shares and labor shares are common within the sector. So the firms don't have their individual capital share. They have a common capital share within the sector, and then the temperature negatively affects TFP. And that dependence can be highly nonlinear. There may be trigger points after which it's really catastrophic. So that dependence is nonlinear, while the dynamics of temperature itself are linear. So you have these externalities, negative externalities in production because they negatively affect the environment. But to think about QE, you need a different friction, which is a financial friction. So let's imagine that firm I sells claims to its capital as different securities. So these are different securities as there's equity, there are bonds that the firms issue, then there are bank loans, and the sum of all these different securities, I'm going to call them A bar, is what the firms issue. What firm I issues of security as at time t is just to finance total capital that they have. And these claims are held by households using, and you can think of basically private intermediaries or the central bank. There are two ways of holding these different assets for households. And both of these holdings come with holding costs. So there are some resource costs in terms of the final good. So it's costly for households to hold assets. And these costs, what do they capture? They can either capture risk-taking, so holding assets of a particular firm may be very risky, and so that is a cost that households have. Or this cost may be a friction, so it may capture costs of financial distress in the intermediary sector. And so both of these are costly and generate holding costs. And so the key to think about in terms of holding securities for households is how this cost function looks like. So for private intermediaries, the natural way to think about these costs is to think about them as being homogeneous of degree 1. So the more private assets these intermediaries are holding and the more central bank debt DT they hold, the more costs they have. And also these costs will be quasi-convex. What does this capture? What does this functional form assumption capture? Is that diversification lowers costs. That's what it captures. And so also these costs will depend on the capital structure of the firms because if firms lever up, if they have high leverage, then they're very risky, and that increases the costs of holding these claims to capital. And also, it will depend on whether firms are eligible for central bank purchases. So there's a subset I wiggle of all the firms I that is eligible for central bank purchases, and that will affect the holding costs for private intermediaries. And then there's an analogous function for the central bank. So I'm not saying it's free for the central bank to buy assets. The central bank has its own cost function. That's what the little wiggle indicates. But it may be different from what private intermediaries experience as costs. And so in such a world, what happens in equilibrium? How do the market portfolio shares of individual firms get determined? So how much capital there is in firm I relative to the total capital stock? How does that get determined? So it depends on the marginal holding cost of assets of this firm. So what happens in the model is the marginal product of capital of every individual firm will be equated to its cost of capital. That part is standard. And then you equate the cost of capital to the safe rate in the economy, and then times a term that has to do with the marginal holding costs of private intermediaries for these assets of firm I, of security S, which are, it's a weighted average. So you see here, I'm summing over all these marginal holding costs, and it's a weighted average of these marginal holding costs times the share of capital of firm I that is financed with security S. So in a frictionless world, these marginal holding costs, you see, it's basically capturing the return premium of firm I over the risk-free rate. So in a frictionless world where you have no financial frictions, these marginal holding costs, they just capture a risk premium. And so it's just compensation for holding a claim to a company that is very risky. In this world, central bank purchases don't matter. And so you'll find many economists who think QE doesn't matter. And so whether central banks or not will do these corporate bond purchases, it does not affect the cost of capital of these companies. And so economists like that think that these premia are just risk premia, and the total holding costs, the private holding costs plus the central bank holding costs, are independent of how much the central bank is holding. And it's also independent of the eligible set of firms for the asset purchase, so that those don't affect holdings. However, with frictions, what you get, if you look at this equation, you get misallocation. Basically, firms that experience high marginal holding costs, if those are financial frictions, then you get inefficiently low capital share in firm I. And so now you have a role for the central bank. First of all, you can, as central bank, take firm I risk off of private intermediaries' balance sheets. So you make private intermediaries safer by taking off risky assets from their balance sheet. So they're holding what the firms issue, that was by A bar, minus that what the central bank is holding. And so if the central bank holds more, the private intermediaries hold less. So that's one way the central bank matters. The second is the central bank finances these asset purchases with safe government debt, in particular with reserves. So you buy corporate bonds with reserves. That makes the balance sheet of private intermediaries safer through this D channel. The third channel is that you can improve liquidity of firm I bonds by making them eligible. By just announcing that bonds issued by fiat are eligible for the purchase program, you make fiat bonds more liquid. And so now within this world, I can now think about what market neutrality is. And so the natural definition in such a framework is to think of a market neutral policy as one that does not affect relative cost of capital of firms. So you do not change relative cost of capital. So the market neutral policies don't affect the market portfolio. How much capital there is in firm I relative to total capital, you don't affect it. So you start from a laissez-faire equilibrium without the central bank purchase program. You do a comparative static to an equilibrium with the purchase program, and the market portfolio has to be unchanged. And so is there a central bank portfolio that will leave the market neutral? The answer is going to be no. It is essentially impossible for central banks to be market neutral. There are two key sources of non-neutrality. First of all, you lower liquidity costs of bonds with your asset purchases. That favors more bond-levered firms. And also the central bank provides safe debt and it lowers private risk exposure in general equilibrium, and that favors more risky firms. And so for these policies to be neutral, they would have to magically offset. And so you need divine coincidence for this to be neutral. Can you imagine a world in which ECB policies would be neutral? Yes, I can dream of one. I can think of a world in which all firms have the same bond leverage, or I can allow the ECB to buy stocks. And then secondly, I can think of a financial market in which private securities and central bank debt are held by different intermediaries. So you have segmented markets for these two instruments, private securities and central bank debt. In that case, my holding costs are separable because they are held by different institutions. So if you have 1 and 2 in the world, so same bond leverage and the segmented markets, then policies would be neutral. But this is a very special financial system, is not in line with what we see in the data, where ECB policies affect premia of assets exactly through the channel, the second channel, which is that these markets are not segmented. And we also observe that firms don't have the same bond leverage. Some firms don't issue bonds at all. And so to think about policy impact of the ECB, we now have to think about costs, fund holding costs that are consistent with asset pricing data. And so how do I think of these costs? So how do costs of capital get affected of firm I? So basically you affect the cost of capital for firm I because the policy affects the risk-free rate. So the risk-free rate changes, but that affects all firms equally. You also affect the liquidity premium of the bonds of firm I, but that change in the liquidity premium gets multiplied by the share of bonds that firm I has relative to its capital. Then there is an effect through the change in risk premium on equity and debt. So let me think about ballpark numbers based on the response to the 2016 ECB program. Can the ECB have an effect on cost of capitals of firms through its corporate bond purchase program? So basically, by saying policy has an impact on the cost of capital, that already, so any empirical work that will say it does have an impact, that will separate the risk premium part of these marginal holding costs from the financial frictions. So that's what identifies financial frictions. And so we know from empirical work that the liquidity effects are small, including by, so this is my co-author, Melina Papuzzi, has documented that the average effect on bonds that are eligible for the ECB purchase program is roughly 15 basis points controlling for risk. So this is not much. So it's 15 basis points. And then, as you see from the top equation, you have to multiply that with the bond share, which is 10%. So 10% times 15 basis points is a very small number. So liquidity is not really important. What is important is risk effects. So that's the red channel. There's empirical work by Todorov that documents that bonds with a 1 percentage point higher premium fall by 50 basis points more. There's other work by Bolton and Kakpachik that documents that firms that have 1 standard deviation higher emissions have to pay a 4 percentage point higher risk premium on their stocks. Also, we know that roughly the average farm is 25% debt financed. So if you would translate the 4% premium on stocks of these high emission farms to the cost of capital, it's roughly 3 percentage points higher for these polluting farms.
Sorry, Monica, sorry to interrupt you. Yeah. You should conclude. Sorry.
Yes, I will. Let me just announce the basic number, which is, so basically then I can think about how can I affect the cost of capital of farms with higher emissions. They will fall by 1.5 percentage point more. And if I take standard numbers for this model, a capital share of 1/3 and elasticity of 3 of goods within the sector, then I find that farms with 1 standard deviation higher emissions have 1.5 percentage points more output and emissions relative to farms with lower emissions. And so let me conclude here. Basically, I showed you that what the ECB is doing right now is the opposite of what it should be doing. It's assembling a portfolio that is dirty. It has a lot of farms that have high emissions. If it wanted to be market neutral, it would have to leave the relative cost of capital the same. Otherwise, it's distorting. But holding bonds in proportion to the amount of bonds outstanding, that's not the right recipe for neutrality. Right now, the ECB favors risky and bond-levered farms. What would be the optimal thing is, this goes back to what Carolyn and Lynn said, have a carbon tax. Then you can do asset purchases that just address financial frictions. But without a carbon tax, having green asset purchases actually are beneficial. Thank you very much.
Thanks a lot, Monica, for your presentation. So it's time to open the floor for the Q&A session. There are questions here. I think there was a question from Filippo for Lint Barrage.
Thank you very much. Lint was a very interesting presentation. Actually, the picture you show of oil prices and the share of green patents is impressive. I know it's just correlation, but nonetheless, it suggests that oil prices can be a relevant driver of green patenting. And my question is, as oil pricing is done in financial markets, I'm wondering whether the effect of financial investment can in turn pass on to the choice of green patenting. So what I have in mind is the financialization of commodity prices. According to that literature, in this financialization, so-called speculative investment, has affected, can be partly responsible for the boom and bust of oil prices in the 2000s. Could you please elaborate a bit on that? Thank you.
Thank you very much. What an interesting question. So if I may make sure that I'm understanding the question correctly, is the question whether different drivers of oil price shocks essentially would be expected to have the same impact on innovation, whether it's a genuine demand shock, supply shock, or a speculation shock? Is that the question?
Yeah, the question is that, so the kind of speculative investment can have an effect on the choice of green patenting through financial markets. So if financial markets can be also determinant for the share of green patenting going on, given the picture, the striking association that you showed before.
And what an interesting question. So through the lens of the standard way we think about the endogeneity of technological change, we would think of inventors as thinking about their expectations of what is the size of the market for a given technology in the future, what is the price of, say, the inputs of generating electricity with a gas turbine. So it's the expectation of input prices that we would expect to have that effect. So, depending on whether price fluctuations are driven by demand shocks or supply shocks, we would quantitatively expect the effect to be different, but qualitatively it could still be in the same direction. With regards to financial speculation, I think the key question is, would inventors expect prices to remain high in the future or not for inputs, say, to, again, generating electricity from fossil fuel resources? So if the expectation of future prices is that input costs will still be higher, then I would venture to guess yes. But I'm not sure. I think it's an interesting question.
Okay, thanks, Lint. There is a request from the floor. Okay, two.
Hi, I have a question for Monica, please. Thanks for the very interesting presentation. The Bank of England published a paper a few months ago by its executive director, Andrew Hauser. The paper was called "It's Not Easy Being Green." I think they were trying to quote Kermit the Frog from The Muppet Show in that headline, if I got the joke correctly. Anyway, in that paper, Bank of England was actually raising most of the concerns or most of the points that you're discussing in your research as to why its corporate bond portfolio is kind of dirty as well, and basically it's not easy to greenify it, I suppose. But one additional point that he raised is that by the nature of the central bank's operating model, they're required to hold the highest quality assets. So when it comes to the corporate bond portfolio, again, it so happens is that not only the dirty firms have more bonds, but also they happen to be higher graded. So the central bank is almost forced to be biased towards the dirtier firms because they need to hold highest quality assets. With corporate bonds, they're already kind of stepping a little bit into the danger territory of moving away from pure government bonds, so they have to sort of hold themselves to that level of quality. And so if they were to step away from that, then it's not that it's impossible, but the question is, can we envision the situation where another institution can step in to absorb the credit risk? So for example, the Treasury, hypothetically speaking. And of course, in Europe specifically, since you're talking about the ECB mostly, we know that smaller firms, and therefore, I guess less dirty firms, actually don't even finance themselves in the bond market. They tend to finance themselves in the banking sector. And again, with the experience of the ECB, we know that it's actually not easy to simply give liquidity to the banking sector in order to incentivize it to lend further down to the smaller corporate sector. We've seen this with LTROs and TLTROs over the past decade or so. So my question to you is that shouldn't we start thinking about the possibility of bringing in a third institution into the picture, such as the Treasury or the Development Bank, in order to start absorbing the credit risk of smaller issues in order to make it easier for the central bank to be financing, to greenify essentially its operating model. And also the second question is, let's remind ourselves that the corporate bond purchases, there's a reason why we call that an unconventional monetary policy tool. It's something that central banks have to do because they currently don't have an instrument that can reach the real economy directly. Right? Central banks only have cash and reserves. Cash is too small, it's for retail use, and reserves are for the financial system. So in order to reach the real economy, whether it's to lower the financing costs or to stimulate production, etc., there's almost this round, almost like a day tour, if you will, of having to go through the corporate bond market. Obviously, right now, almost every central bank is looking at the possibility of introducing the central bank digital currency, which will be a way for the central bank to have an instrument that reaches the real economy directly, not through the banking system,
Sorry,
directly.
I have to ask the question.
Sorry, so the question is, with the presence of a credit-absorbing institution, such as the Treasury, and with the introduction of a new monetary tool, such as the central bank digital currency, can't we just let the corporate bond portfolio sort of grandfather, or as I heard earlier, grandparent itself, and focus on the new ways of financing the economy for the central bank?
Okay.
Sorry for the lengthy question.
I think you're raising an important issue, and this is also what when you're looking at the current portfolio of the ECB, you see that this is going in the wrong direction. Could you do better? Absolutely. There are bonds that the ECB could be buying that are greener. So it's not, the ECB is not somehow magically forced to buy this portfolio. So it's not impossible. But there is this tension that corporate bonds, they are safe, they're highly rated when within the firm you have a lot of tangible assets. So you can have the this is the paradox. You can have a firm that is highly risky, it's super exposed to transition risk, so has a high stock return, but has a very safe corporate bond rating because it has a lot of tangible assets. And that's the tension that central banks face. But you don't need to limit yourself to corporate bonds. I mean, let's remind ourselves what the Swiss National Bank does. It buys equity. So it does exactly assume more risk than the ECB, and it's doing fine. So I would challenge the ECB to say, why limit yourself to corporate bonds if other central banks have already started buying equity? And that's important because, as Lind was saying, you want to we need innovation to get us to a carbon neutral future. That innovation has to be financed. These people are going to be entrepreneurs that have new ideas. They will be young people without any tangible capital. They will not be able to issue bonds. So you need to buy their equity. And so we need to say central banks have to think about how to get us there. And they have responsibility to share in getting us there. And that means we need to think about equity. We also need to think about private public cooperation in private equity. The private equity market in Europe is not working as efficiently as it should. It should be much stronger. And so central banks should be involved in thinking about private equity for firms. Or alternatively, if this is not what you want to do because you think this is outside of your capabilities, then think about what the Bank of Japan is doing. They have lower capital charges for banks that give loans to firms that come up that are young and have greener technologies. That's an alternative. Go through the banks. But I do think that central banks can do better than what they're currently doing.
Fantastic. Thanks, Monica. And again, really a great discussion, great question. Then we move to the next session in 5 minutes. You have a super quick coffee break if you are able to, and we are going to reconvene here at 5:20. Thanks.
Thank you.
Well, while they prepare these things, we are waiting for a connection from Chicago, which apparently is a little bit difficult to get. Let's see how it goes.
Good afternoon. Welcome to this last session, but extremely important of this conference. And if Governor Risco is online, he'll chair the panel, the final panel of this very, very interesting conference. Ignazio?
Yes, just to understand, I suppose that we are not in. There is, I suppose, Michael Greenstone who is missing. Is it correct?
Yes. Yes, Mr. Greenstone is still missing at the moment.
Okay, so we start with a missing panelist, but I think we can cope for the time being with that. I welcome everyone to the closing session of this conference, and as Governor of the Bank of Italy, I'm really glad to moderate a panel discussion about the challenges of net zero policies and the role of finance to spur the transition in light of the coming COP26 meeting in Glasgow. Arresting climate change requires achieving net zero greenhouse gas emissions on a global scale, and this has to take place by mid-century. It is an urgent task, one that somehow, if we don't act now, acting later could be very costly and might turn out to be also ineffective according to many analyses. In July, we had the conference in Venice on climate change that took place under the Italian G20 presidency, and there major global actors were convened, including G20 finance ministers and central bank governors, to discuss the policies and actions needed to achieve the 2015 Paris Agreement goals. Overall, the participants of the conference agreed that climate change poses huge risks to economic resilience, to financial stability, to human well-being. All these are obviously things that we agree very much upon, but really the issue here is enhancing international coordination, which is crucial to support an orderly and just transition at global level. We have seen these increases in gas prices very recently, very huge increases. Energy prices are on the rise, and there is a lot of complaint around the world about this, so the governments are acting to limit that. Now, obviously, we need an orderly transition, but we need a transition, so relative prices have to change. And this issue is really something that is not easy to obtain, and obviously to have everybody agreed upon on it. It is now, however, quite clear that while COP26 is approaching, countries' commitments to reduce emissions and meet the mid-century targets are not enough. The current nationally determined contributions of all the parties involved, 191 countries taken together, imply that by 2030, more than a 15% increase in global greenhouse gas emissions will take place compared to the 45% reduction that is considered to be necessary. Now, a successful transition requires, I think, more ambitious plans, and this has been the discussion on which this conference has been taking place, and certainly more ambitious plans together with closer global cooperation. The presentations that we heard today shed some light on what policies can be considered as optimal to reduce greenhouse gas emissions, and this without hindering or trying to hinder as little as possible the economic growth prospects at country and global levels. Now, enacting such policy, however, is, as we all know, very difficult. It's not an easy task. And this is so because there are very diverse socio-economic conditions in different countries at in the world level, and also the political difficulties that are present and the actual willingness to act that seems to be lacking in a number of countries is something that we have to consider with care. And takes place especially in those countries that are at an earlier stage of development and whose economies are more dependent on fossil fuels. By the way, fossil fuels are still heavily subsidized, and therefore the actual carbon price, once one takes them into account, is very, very low, perhaps even negative. Now, the question is how to align the incentives of these countries with those of the global community. Can a different mix of public policies and market-based mechanisms across countries be effective in supporting emission reduction and investment in green infrastructure and technology innovation? While each country is clearly responsible for putting in place its own mitigation strategy, the issue here is whether there could, how we could get the mutual benefits from policy coordination, which are potentially very large. I would say they're essential. We did not have coordination at the time of Kyoto, and even if we had some plans, we had engineered a market for emissions, permits for emissions and so on, but it did not work globally. So the global coordination is essential. And this is what we discuss in fora like the G20, like the G7, where multiple options for harmonization and collaboration are really considered. But I would say more at the technical level than at the political level. There is a difficulty at the political level that has to be overcome. And in addition, there are various ideas around setting up a club of willing countries. This has been suggested, among others, by Bill Nordhaus, who introduced our meeting in Venice. And the question is whether these proposals are really viable. Now, we will discuss this and other topics with our distinguished speakers. Certainly there will be Gita Gopinath, who is the John Swanstra Professor of International Studies and of Economics at Harvard, and is currently serving as Chief Economist at International Monetary Fund. Michael Greenstone, whom I hope will join us soon, who is the Milton Friedman Distinguished Service Professor in Economics at Chicago, and also a director of the Interdisciplinary Energy Policy Institute there. Klaas Knot, who is president of the Netherlands Bank, member of the Governing Council of the European Central Bank, vice chair and upcoming chair of the Financial Stability Board, and last but not least, obviously, Lord Nicholas Stern, who is the IG panel professor of economics and government, chairman of the Grantham Research Institute on Climate Change and Environment, head of the India Observatory at the London School of Economics, and one of the main contributors to the issues already in the early 2000s. We know about the report that you put together, and I remember your words when we had the G20 meeting in China. I think you were connected, and you were saying that at the end the technology will make it. And so this is also an issue that we may touch upon. So I welcome you all joining now us online. And during this conversation, we profit from your thoughts on how to convert commitments into policy actions, and in particular, how to reap the benefits of acting jointly. And I think that we may start with the first round of questions. We have planned for 25 minutes, more or less. It means 6 minutes each. We'll see whether Michael will join. But I would start with Nick, and then followed by Gita and Klaas. And so this is my first set of questions to Nick. A successful transition to a low carbon and climate resilient economy obviously requires a policy framework that is both credible and comprehensive. This is in order to support investments, and those investments I mentioned before, through structural policies that set clear market expectations, including carbon pricing and the phasing out of fossil fuel subsidies, as well as regulatory measures. Now, what policy framework do we need to achieve a successful transition? And how do you see the roles of both the public and private sectors, as well as the interactions between the two? What are the macroeconomic implications of different approaches, and which approach should you prefer? Obviously, 6 minutes are not enough to answer these questions, but I'm sure that you will give it a try. Thank you, Nick. Floor is yours.
Thank you very much. The first thing to recognize is, as you underlined, Governor, from the beginning, that the risks we face from inaction are immense, much bigger actually than in standard economic models, which are seen as rather strange by the scientists who help us understand these risks. But the risks are immense, and the time is short. And you underline that, I want to underline it again. The way forward is around investment. And this is actually a special moment in history where not only that our actions are decisive, but we can see that this is a moment where we can identify the investments we have to make. We can recognize their scale and their geography. We have to invest, and I'm sure you saw, Governor, the G7 paper, which we prepared for the UK summit in June. The investments we need to make as a world, about 2 or 3 percentage points of GDP, over and above where we are now. And of course, we have to change the composition of investment as well. So this is a moment where the policy question is, how do we stimulate the investments that we need? And we can describe roughly what they are. We're going to learn a lot along the way, but we can describe how to start, both in scale and in nature. That's very different from standard economic analyses in these areas, which will say, get your institutions right, get your prices right, get good governance, and let investment be what it may. The markets will work it out. This is different from that. It's that story is part of the story that we have to follow. Of course it is, because we need the markets to give the incentives. But this is investment with a purpose, investment that we can identify. And the policy question is, how do we generate that investment? Now, that's the large measure, the macro story. Then we move over to the micro and the structural. And we say, what are the key market failures here? How do we understand them? And what are the key absent markets? It's not just market failures, it's also absent markets. The market failures, well, number one is the greenhouse gas externality. Let's always keep that top of the list. But we have 5 other very big market failures, not marginal, not footnotes, central. So there's the research and development story, intense in this context. There's the capital markets in the context of very rapid change. We know that they handle risk only moderately well, to be kind, and there's a situation where the investment story is very strong. There is the whole story of networks, electricity networks, recycling, public transport, absolutely core, and their markets need foundations in order to work. Not necessarily public ownership, but they need foundations. Great deal of information is necessary. Mark Carney's been very strong on that. Consumers need information, so you're going to need quite a lot of regulation around transparency and information. And last but not least is the whole story of what we call co-benefits. Air pollution, much of it from fossil fuels, kills somewhere between 5 and 10 million people a year. The death rate in the world is a bit more than 50 million. This is huge in this story, and with very big macroeconomic consequences. So let's remember that it's not just one market. If we look at the first one, top of the list, the greenhouse gas emissions, let's remember that we live in a world with increasing returns to scale and a lot of uncertainty. Unless you gave up economics after the first year, you would know that price mechanisms with increasing returns to scale and lots of uncertainty don't necessarily do everything for you. They do a lot, We forget the role of the price mechanism at our peril. It's just a mistake in economics to say that economics says that the carbon price is the most efficient way to do it. It's somebody who stopped economics too early. A statement that says carbon price must be at center stage, I think we'd all go along with. But it's uniquely, obviously, the only thing that we have to do. It's just dead wrong and very misleading. Absent markets are very important here. We can't buy the technologies that we'd like to buy because we don't know what they are 20 years down the track. We know enough about them now to get on with it and start making our investments. But absent markets are very important. Transacting on the carbon price market 20 years out is not easy to do. Those markets are not there. We know, whether we follow von Hayek or Keynes, I hope both, and Schumpeter too, all three of them, we know that expectations are fundamental. And so clarity, as far as we can. Governments can't do total commitments, but we can build institutional structures which give us as much reduction in uncertainty as we can. So that's the story of investment and the story of policy to realize it. I haven't got time to go into the financing of that investment, but we live in a world where planned savings is in excess of planned investment. The extra investment that we're describing should be macroeconomically feasible at a global level, but finance is about getting the right kind of finance in the right place at the right time, and the detail of that matters enormously. Finally, let me say something about coordination. We all teach David Ricardo and trade and point out the importance of an integrated world economy, and we're right. But there's something here which is so much stronger than that. Expectations. This is about realizing investment. If governments move together and say this is the direction and the scale of investment that we seek, then we all benefit from those coherent expectations, country by country. If we move ahead, we get the economies of scale. The economies of scale here are immense. I mean, who would have thought, 15 years ago, when we did the Stern Review, who would have thought that the cost of solar would come down by a factor of 10, round the clock solar, and outcompete fossil fuels in most countries of the world, and wind also. Scale is a big part of that story, and moving together gives you the scale. And that is also enormously important, not always in our standard models. And of course, these are global public goods, so coordination is crucial. But finally, there's coordination in the world debt markets. Geeta lives that, and I'm sure she'll come back on that. But through COVID in particular, but more than that, through this last decade, stress has been building up, particularly on debt for emerging markets and developing countries. Given that this is a story of investment, we have to manage together as a world that debt if the investments in emerging markets and developing countries are going to take place. This is, I've been doing economics, teaching economics for more than half a century now, and I've never been in a situation or seen a situation where collaboration is more important than now. Thank you.
Thank you very much, Nick. Indeed, you are also the head of the India Observatory. So talking about emerging markets, this is clearly a crucial area of the world. And in our G20 discussions, I think we got good collaboration at the technical level. We were able to restart what the Chinese started, this Sustainable Finance Study Group, and we have been able to transform it into a permanent group. It is co-chair, and this is very interesting because they accepted our proposal by both the China and the US. So we have both the two largest polluters in the world as well as the two largest economies. Putting together at the political level the willingness to act in a cooperative framework is more difficult than at the technical level. And any strains that we have at geopolitical nature really matters. So we have to keep doing and keep saying, but then at a certain point, it is essential the response of the population. So this is crucial. Now, going to
can I just say on that particular point, what we have to show, and I believe we can, is that if we get it right, this is the growth story of the 21st century. Discovery, innovation, investment. And not that it's some kind of horse race between environment on the one hand and growth on the other. That argument is developing. And as we show that, then I think we start to change politics. But we have to be able to finance the investment. And for a country like India, low-cost finance on scale is critical. And the international financial institutions will be crucial for that.
Yeah, very well. This is, in fact, Gita, what I would ask you to help us with, because clean energy investment in the developing and emerging economies is only a part, a fifth of the total, but these are the current countries which now have low energy demand. But there are hundreds of millions of people who are still lacking reliable access to modern forms of energy. And they still have low per capita emissions, but they will account for the bulk of emissions growth in the coming decades, unless stronger action is taken to transform their energy systems using the suggestion Nick gave us also in terms of investment, economies of scale, and the interaction between the two. Now, what do you think are the available options for building a successful strategy to reconcile developments with transition to net zero? Obviously, this is not the only question that you may answer. How can private finance also help? But I'm sure that at IMF you are thinking a lot about this. So if you could give us some light about this thinking, we'd be very grateful. Gita.
Thank you, Governor, and happy to give you our thinking on this particular question, more broadly the question of getting to net zero emissions in less than 30 years and the financing needs that would be needed. The kind of change that we need is profound. We're talking about profound sectoral changes. We are trying to transform the world from being one that is still heavily fossil fuel dependent to one that moves towards low carbon energy sources. So the transformation is profound, and the approach we believe is necessary to make the transition happen without having the kind of economic costs that people worry about has to be a comprehensive strategy. So what exactly is that? What we have is what we call is a bit of a three-pronged approach. One prong is one where you have green investments and support for green R&D. The second prong is carbon pricing and transparency on carbon exposures. And the third is measures for a just transition, just as in JUST transition. And by that, I mean just transition, not just within countries, but across countries. So let me come in here and I will speak specifically to your questions on emerging developing economies, but they're very tightly related. So completely not unexpectedly, I agree with what Nick said about the need for green investments. And while carbon pricing is important for getting the relative prices right, you also need to make sure that we have enough supply of clean energy that comes out at affordable prices. And we just recently put out a note for the G20 where we reviewed what these costs would be like. What kinds of numbers are we talking about in terms of investment needs? And what we estimate is that globally, about $6 trillion to $10 trillion in additional, the important word here is additional, global investments are needed in the energy sector. And importantly, you need to be reallocating also whatever investments are currently going on, and these additional investments have to be tilted towards low carbon emission sources. And this is, so we are talking about cumulative 6 to 10% of global GDP over 10 years, right? So this is very possible. It can be done, and especially given what we're trying to prevent, this is absolutely crucial. Now the question is, where does this money come from? The 6 to 10 trillion cumulative additional global investments that are needed over the next decade. We are talking about, we estimate that about 30% of that would come from public sources, and including the fiscal packages that are being announced in part of the recovery plans that countries have from COVID-19 pandemic. We are encouraging countries to use this unique opportunity to invest in this green transition. So that's about 30% of the coverage. But then there is the remaining 70% that would be from private sources. And this would require incentivizing that kind of private investment. So what would that take to ensure that you're getting the right levels of private investment that you need? And this will require, in our view, one, of course, predictability in terms of the regulation and the pricing that you're going to put in place, predictability on carbon pricing, because that provides market signals about the direction in which subsectors are headed. But we also need what we call a climate information architecture, which is missing and woefully inadequate at this point. So carbon pricing provides the incentives to reallocate resources from high to low carbon activities and to improve energy efficiency. But at the same time, to steer the finance towards these sustainable investments, you need just greater transparency. You need this climate information architecture. And that requires three things. One, you just need high quality data, which is reliable, comparable across countries. You need, secondly, a globally harmonized and consistent set of climate disclosure standards. And third, you need globally agreed upon principles for climate finance taxonomies and other classification approaches to align investments with climate goals. So we need a coordination that Nick mentioned in multiple dimensions. And then lastly, on the just transition policies, we do talk about the kinds of income transfer schemes that will be needed to make sure that the most vulnerable are not affected by the transition. But here I'm going to focus on the cross-country dimension, which is basically making sure that there is enough financing for low-income countries to undertake climate mitigation policies, but also in the interim climate adaptation policies that they will need. And so much more needs to be done on that front. It's been woefully inadequate. It will require advanced economies to live up to their commitments to deliver $100 billion a year in climate finance. And also importantly, a significant portion of that climate financing will have to be in the form of grant financing, given that many countries have very elevated levels of debt and are already in debt distress. At the IMF, we are investing, we are building up a resilience and sustainability trust. We are in the process of building such a trust, and which will basically involve countries, some countries with very comfortable external positions, rechanneling their special drawing rights towards this trust to support these kinds of transition, including the green transition. From an emerging developing economies perspective, it will require more than just finance. It will also require technology transfers to make sure that they're able to do the necessary investments that they need. And the question is, what you said is absolutely right. They are growing economies, they have growing energy needs, and so the trade-offs might seem much more starker. But at the same time, there are two things that are working why this is the right time to make the switch. One is that alternative energy fuels renewable energy has become much more cost competitive with fossil fuel sources. And so therefore, this could be the opportunity to just leapfrog towards newer, cleaner, and less polluting energy sources. And so therefore, you can use this as an opportunity for development to make that investment to transition to this. The second is that many of these countries suffer from the problems of bad air pollution, and which is then affecting their health, their morbidity, their mortality. So there are significant benefits, the core benefits, again, as Nick mentioned, that should be particularly salient to these countries. But again, just to combine the whole piece, which is that they will need the financing, they will need the technology transfers, and all the different earlier points I made about making sure that they have access to this kind of financing is absolutely critical.
Okay, thank you very much. So we have obviously the challenge is large. Also, the financing is very relevant, even if manageable, as Gita said. How much of this could come from the central banks? I suppose that those who have the legitimacy to act are national governments. They are the ones who can somehow provide the incentives that Nick mentions to investment, the financing also to the developing countries and perhaps some emerging economies that would be needed in the 100 billion plan that Gita was mentioning. And obviously they can do something themselves in carbon pricing and the like, regulation. But there is somehow a lively debate, Class, we are engaged in that almost daily, on how central banks and supervisory authorities could integrate the impact of climate change and climate policies into their strategies. We heard, you were not there, Monica Piazzesi complaining about what we do at the ECB, saying that we perhaps are too much obsessed with market neutrality, and in this way we do not favor green industry. There might be something on that. I would not differently than others. I don't think that QE has encouraged debt emissions, public debt, which are at the end, through general equilibrium effect, had the results that Monica was mentioning. But this is an issue. And also supervisors are asked to ensure that the risks are properly accounted for by financial intermediaries. So the question to you is clearly what central banks and supervisors role can play in practice, and especially in the light of your experience at the DNB, perhaps you may help us in making progress on that. Class, the floor is yours.
Well, thank you very much, Ignazio. And I did pick up the last 10 minutes of the debate before the break, so I heard the comment on buying equities and other things that possibly we could do. Well, I won't comment on that, but let me just try to confine my comments primarily here to what actually climate change might mean for financial stability. I mean, by now we are very much aware that it can potentially threaten financial stability. It'll impact the economy as a whole. And I believe with the COP26 now in view, there is clearly strong momentum to act on this. Just to illustrate the momentum, last week we were all in DC, and I think climate change was also there top of mind at the IMF World Bank annual meetings. I had the privilege of presenting the so-called early warning exercise. The title of my exercise was When Tomorrow Becomes Today. And it was mainly about sort of what could happen to the global economy if climate change were to accelerate, if policymakers were to become behind the curve, and then all of a sudden would have to step up their mitigation activities in a way that would be much more abrupt and much more shock-wise than a smooth transition would be. Well, it is pretty clear that that can have quite lasting and quite substantial impact on growth, on financial stability, and what have you. So there is a strong urgency here to act, and I think that should be pretty clear. It's interesting that thinking through the transmission of such a shock, it also reveals that there is actually a lot that we don't know. How specifically, for instance, climate change will impact our financial sector, how specifically the impact will be on the economy. There are some things that we do understand, but there are also some things that perhaps we don't understand yet. It will change relative prices, absolutely, and therefore it'll likely change the volatility of inflation. But will it also lead to higher inflation? That I think is still a question that is out there. So also in that context, I think the topic of this conference is pretty apt. It's good that we focus now on research, on the things that we can do to grasp a better understanding of the macro impacts. And I believe a lot of work that is done in the academic world here is also indispensable to that extent. Now, what we have been doing at DNB, I can give you a few highlights. I mean, already in 2017, we did a sort of test which, to what extent institutions in the Netherlands would be exposed to physical risks. You know that large part of my country is below sea level, and climate change is, of course, going to affect the torrential downpours of rains, the sea level itself, etc. And then we moved on by embedding such risks also in what we call macroprudential research. We did a top-down stress test, which, for instance, demonstrated that if we are too late with acting, that for the Dutch financial system, losses could amount between some 48 and 159 billion, which is quite a sizable amount if you compare that to the amount of capital held in the industry. So there's a lot we still don't know. There's a lot that we do know. I completely agree with, but I think it is indispensable to get the relative prices right and let the market actually do the bulk of the adjustment for us. We have looked specifically at DME also at the impact of the Fit for 55 plans that the Commission has issued. We looked at the competitiveness consequences, the potential competitiveness consequences of that. There's a lot of concern also within the Dutch corporate sector, but we believe that as long as the proceeds are channeled back in a productive way, that the effects on competitiveness can be limited. And of course, also a carbon border adjustment mechanism might further mitigate the negative effects on competitiveness in the industries that are relatively hard hit. Now, to your specific question, where does it sort of specifically impact on central bank tasks and mandates? Well, inflation, I already mentioned, but I also think that there's the broader question on the economy at large, where central banks, even if they are not responsible themselves for activating certain instruments, what we can actually offer is a bit of thought leadership. I think we have a significant amount of staff, research staff, that can actually look into these issues, and very often the governments that sort of avail themselves of these instruments do not have the same analytical capacities to do policy-related research. So jointly with the academic world, again, that's why I think this conference is very well suited, but together with the academic world, I think there's a lot that central banks can do there, even though we do not have an explicit climate objective, but it does touch upon various parts of our mandate. Financial sector, I think disclosures are absolutely key. We need to get this pricing right, this price exploration phase that we have to go through. So a lot more information will have to be disclosed. Well, the financial sector, I think, is key in allocating capital flows, but it's also key when it comes to disclosures. And I'm very glad to see that we are now working from the FSB side, also with the ISSB, which is a branch of the IFRS, to build a global set of consistent and coherent and comparable disclosures. I think that will be absolutely a key element in this sort of early phases of what we need to do. Well, at the ECB, we will also incorporate climate-related risks into our financial instruments, into our own financial risk management, so the protection of the ECB's balance sheet. Of course, we are engaged in a lot of financial transactions with counterparts, where collateral issues, etc., play a role. Ratings that we believe should also better take into account climate-related financial risks. And finally, I could also mention that, for instance, at DNB, when it comes to our own reserves, of course, we have to practice what we preach. We have to align our own reserves with the international sustainability goals and the corporate social responsibility standards. At DNB, we are building a portfolio of green bonds, and we're also investigating whether we can have our equity portfolio also be guided by explicit carbon reduction targets. So that, I think, is a snapshot of what we are doing and what I believe we can do from the central banking side.
Thank you very much. Thank you very much, Klaas. Obviously, this is what we should do. Not only, and many of us are doing it. Our balance sheet now is really very much green as far as our own funds are concerned. Obviously, disclosures will be essential. IFRS accounting will certainly be crucial, and there will be a need to improve on the ESG scores that clearly are still very much deficient up to now. We are doing research, working on this, trying to account for the changes, the difference, and so on. And this is in the roadmap of both the FSB and the Sustainable Finance Working Group. So I'm very optimistic on this side. I think this is something we are making clear progress. It will go to the G20 leaders. It goes in the COP26. This is something that helps clearly also the financing of these enterprises or corporations to somehow be directed in a particular way, and all this is good. But there is certainly an issue which I think we should take into account, and the issue has to do with the fact that relative prices of fossil energy versus renewable one will necessarily have to rise. And the question to me is how large, and obviously I'd like you to share that and provide some answers, is how large and widespread do you think the risk of social discontent might be? And by which policy measures could it be contained at both national and global level? What are the risks that transition may be less orderly than we hope? How to make really the private sector to be a willing partner of national governments? Plus mentioned this early warning exercise. It focused on the tail risk, extreme tail risk, that we may have to consider if there was a, I would say, global catastrophe. But you know, my impression is that these climate change effects are extremely dangerous, but they are not harmonized. It is not nothing like the global financial crisis or the pandemics. They touch they somehow touch all of us in different ways at different times. And so to have a social response like the one we had, for example, in the last couple of years, is not easy to engineer. So the question is how to make these, how to somehow, this, we discussed this at the G7 very much in Washington, how to somehow provide with the proper information that would convince most of the population at the global level really to understand the need for going in that direction. I mean, I understand that Gita said very clearly, these 100 billion, please use them, rather than keep saying that they are there to be used. But another question is also whether we have enough information about different progress by different countries. We are talking about carbon pricing. We have explicit carbon pricing, but we can also produce figures of the implicit carbon pricing. How did that be possible? Could we move in that direction? So who wants to speak first? I don't know, Gita.
You know, I think this is an absolutely critical point, which is, can we get this all to work politically? And at a time when energy prices are spiking, I think it's become even more salient. This is, I mean, it's for sure, this is a difficult question, a difficult way to solve it. But our view, of course, has been the following, which is that one, that sequencing is important. What does that mean? That means that when you are raising carbon prices, it would be good to have a predictable path where you're backloading the increase in carbon prices to some extent, while using the near term to ramp up supply of renewable sources of energy and also the needed investment to get better storage technology. So this becomes a much more resilient source of supply. So that when the actual true carbon price kicks in, it's a great signaling device for people to invest now. But for those who have to actually pay the price in the future, by then you have these alternative sources that makes the switch easier too. So sequencing is one important part. The second is this will require transfers. There's no doubt about it. So you're going to increase your revenues through carbon prices. Then you also need a system where you can transfer this back to those who will be deeply affected by it, and especially to vulnerable households. So those kinds of transfers, and you're seeing that in multiple countries actually, where they are raising carbon pricing on one hand, at the same time, say, cutting income taxes for some section of the population or making transfers to it. So you see that happening. Now, despite all of this, you might still have the concerns that carbon pricing doesn't work, in which case there are some alternatives, like you said, which is regulations, so-called rebates, which is that you tax those who on average have higher emissions and rebate it back to those who have lower emissions. So those might be more politically feasible, and that's certainly another approach that we have to take. All of this also becomes a whole lot simpler if for countries in the world, financing is just available more easily to deal with, with these kinds of transition risks.
Thank you very much. Obviously, every time that we talk about transfers at the international level, we have someone who points out to moral hazard and how to cope with the moral hazard that somehow is behind all the support that we may provide to countries hit by crisis, or to, in this case, to countries which do not have the means really to act. But I understand this is an issue that has to be dealt with at the political more than at economic level. Nick, you may join perhaps.
Thank you. So how do we get political buy-in to something that makes enormous sense from the point of view of the cost of inaction being far bigger than the cost of action, something that could well be, should be, if we do it well, the growth story of the 21st century, investing in the technologies of this century, not in the technologies of last century. How do we mobilize political support behind that, given that the transition is complicated, given that there'll be dislocation, market prices, and of course in the activities of people? Well, I think the first thing is to insist on the growth story. And we've started to move in public discussion away from the horse race that I described before of environment on the one hand and living standards on the other. So the more we can show that, both analytically, but of course through example, the greater the force behind the story. The second now is, and related to that, is the private sector is telling that story itself. It's showing how it can reduce cost. It's showing how a responsible firm on the whole does better than an irresponsible firm. Now, many of us have the privilege of working in universities. We get older, but the young stay the same age. And they are very well informed. They're pushing very hard. They're not just shouting at us to do something. Our undergraduates at the LSE, and I'm sure at Harvard with Gita and other places, they're actually working on what to do. And they understand what to do. And they know which firms are doing those things. And they know which firms are not. Unilever, transformed under Paul Polman over his 10 years as CEO, gets 2 million job applications a year. They get the best. And all sorts of other reasons. They get the patient capital. They get customers who think. That story of this being a growth story, both at the macro and at the micro level, is increasingly coming from the private sector. So I think they will be very important actors in that. Thirdly, we can bring costs down through using standards. Let's not make the mistake of only carbon price. let's not make the mistake of marginalizing the carbon price. The carbon price has to be center stage. But let's not make the mistake of only carbon price. In Europe, Ignacio, as we all know, we banned the incandescent light bulb. It was a monumentally inefficient way of lighting. We banned it, and very quickly alternatives came through. This is not picking winners, it's spotting disastrous risks. And if we act on those disastrous risks, with the knowledge that there's quite a lot of things out there, but let the market work out what the alternatives are, we find that we come up with things very quickly. Same with CFCs, so many examples where actually standards in a world where we have increasing returns to scale and big risk are part of an efficient response because they reduce uncertainty about going to scale. Similarly, for in the UK, like many other countries, you won't be able to sell an internal combustion engine car after 2030. That actually is part of an efficient package, along with carbon pricing, in order to create the confidence that we need for the investment, which is at the heart of this story. So that brings down cost. But also, and I'm right with both Klaas and Geeta have said, and I've pushed it very hard myself, is go for things like carbon tax, which have revenue, and then use that revenue to protect people who, over the shorter term, would be hit harder by the price increase. That is a very important part of the story. The international story of equity is in large measure about low-cost capital. We used to say low-cost capital and technology transfer. Technology transfer is still relevant, but it's actually quite remarkable how the availability of those technologies has opened up around the world. India is an innovator in low-carbon cement. India has actually played a big role in driving down the cost of LED light bulbs. India has now got so many examples of round-the-clock solar coming in cheaper than fossil fuel electricity. So for me, center stage for getting the job done in terms of investment, center stage for getting the job done in terms of equity is low-cost finance for developing emerging market countries. That's at the heart of the story. That's why the IFIs are so important in all this, and why bilateral support is important too.
Thank you, Nick. I think that you touched also an interesting point when you mentioned the fact that in the population there is a large share of young people who now is very much willing to go in that direction. There is also some older persons like the Queen of England who is asking why we do not act. And I think this is a nice connection. I wonder whether Professor Greenstone is connected at least on the phone. Because
Hi, I managed to join on the phone.
Yeah.
We had a crackerjack team of 5 or 6 people from the Bank of Italy and 3 or 4 people here, and we gave up, and now we're on the phone. So.
Okay, anyway, you are there, so I may raise a question to you that we have been discussing also the social costs of in not acting, and you have underlined many times how useful it is to use the social cost of carbon as an informative tool for policymakers, as a proxy of the cost for inaction. So how do you see the possibility of making regular comparisons between the social cost of carbon and the current carbon rates, including both implicit as well as explicit prices across countries? Could this help policymakers, decision makers, but also the market, the private firms, to make their policy more consistent with their climate targets? The idea of trying to somehow combine the two is really behind much of the suggestions that we are discussing at the G20 level. Maybe you could give us some views on that, and then we can move to class. Michael, please.
Yeah. Yes, thank you. It's my great pleasure to join, if only by audio. And of course, it's such an honor to be on this panel with people I admire so much. So I would just back up, and I hope this is not disruptive to where it sounds like you guys are having a very productive conversation. And what I wanted to say, and I will say it somewhat provocatively, is that, of course, climate change is a critical threat for us and for the planet. But I think in order to tackle it, it is actually best framed not just as a climate challenge, but I like to think of it as the global energy challenge. And I think of the global energy challenge as kind of think of it as a stool that has three legs. The first leg, and this is the slightly provocative part, is that every society, and it's going to look very different if you're sitting in London or if you're sitting in Mumbai or if you're sitting in Moscow, every society around the world is extraordinarily focused on how to make sure they have access to inexpensive and reliable sources of energy, and that the inexpensive and reliable energy has unlocked such amazing gains in income around the world over the last few centuries. And so I think of that as one leg of the stool. But the other two legs are that the way we have constructed energy markets have basically allowed two other issues to enter, two environmental issues. One is you can think of as local environmental pollutants like air pollution, which is reducing the life expectancy of the average person on the planet by more than 2 years currently. And then the third, of course, is why we're here, which is the same fossil fuels that societies have relied on are increasing the odds of disruptive climate change. And I think, and so the reason I want to back up and frame it like that is, I think if you only look at the climate part and don't think about how different societies, and people are going to see it very differently where they are trying to balance between those three goals, we're going to end up in a place where we're not really communicating well with the different parts of the world. And you're beginning, and that has become, I think, it's painfully obvious in where I do a lot of my work in the state of Bihar in India, where the average person in Bihar consumes about 200 kilowatt hours of electricity per year. In the United States, it's like 13,000. You're also seeing it in very wealthy places like Europe right now, where there's lots of outrage about high energy prices. And so I think it is unwise to talk about climate without seeing that whole picture and trying to figure out a way to balance between those three goals and the various trade-offs. So now let me just turn to actually what you asked me to talk about, which is the social cost of carbon. I like to refer to that as the most important number that you've never heard of. And what the social cost of carbon is, probably in this audience is not necessary, but I'll just repeat it. It's the monetary value of the avoided damages, or say of the damages of releasing an additional ton of CO2. And I think basically every policy that we have relative to the stock of CO2 in the atmosphere, or the 30 to 5 or 40 billion tons of CO2 emitted across the planet currently is marginal. So it's a super useful concept. And I think it is a great focal point for where carbon taxes should be. It's a great focal point for policies that are not carbon pricing. I think they need to be evaluated on their cost per ton. And if they end up being more than the social cost of carbon, then I think they need to be scrutinized very carefully. And if they end up costing less, then that's terrific, and we should do them. And so having a reliable social cost of carbon, I think, is very valuable in kind of guiding climate policy. I think you were also asking about organizations, corporations. It can also be very useful to them. I think what we're seeing, this was probably, if we had this 1 year ago, we would not have been able to say this. But today, I think we can say the demand for voluntary action is really growing by leaps and bounds around the world. And corporations are looking for guideposts on how to judge how much they should be doing, and I think the social cost of carbon is an excellent guidepost for that. So I think it's kind of a North Star of where we should be headed. It affects carbon. It's a guide for carbon pricing. It's a guide for policies that are not carbon pricing for when they're more expensive than we might like them to be, and it can be useful for voluntary actions as well. But
thank you very much.
I think that's yeah.
Thank you, Michael. Really, on the last part, we have had some discussion on the issue of trying to have a better evaluation of the cost per ton and so on. I think this is very much in the making. I think both the OECD, but also the IMF and other international organizations are trying to put together the gaps, to fill the gaps that we have on all this. Klaas, do you want to say something on this issue also?
Yeah, thank you, Ignacio. I just wanted to come back to the social discontent, because I do think that is something that we need not underestimate. And I think, I guess this is another perspective to reiterate what I also said before, that the issue of timing and sort of an early start is really crucial here, because I think the amount of social discontent could be sizable if we manage the transition very badly. Now, what is a badly managed transition? That's probably a transition which is very shockwise and which will give people the feeling that they have no choice, that they did not have the time to respond and to adapt, etc. And I think that is what the current surge in gas prices is actually a manifestation of. That if you give people, households, businesses the time to move away from fossil fuels to an energy mix that is more based on renewables, then of course, at the end of the day, everybody will understand that the price of fossil fuels will have to go up, and that they will have to go up dramatically, actually. But if they don't, if the time is not there to adjust behavior, then I think this is very much a recipe for public backlash. So the more gradual we can make the transition, and there I think, again, it's up for the governments to set out very clear transition path, so that you provide as much certainty to the private sector also where you want to go. One of the reasons that I'm also hearing that businesses is reluctant to invest in certain green technology is because of, let's say, the unpredictability of the political process. That, okay, we have commitments, we have governments committing to certain targets, but you know, after 4 years, at max, there's another government, and there have been changes in course earlier on, etc. And so predictability and gradualism, I think, is key in managing this well. And that's the only way in which we can continue to have public support. And then the second point, again, tax revenues, to the extent that this brings in new revenues for the governments, this should not be seen as the government increasing taxes on its citizens, but rather these revenues should be put to use in a productive fashion to finance green technologies, to perhaps reduce income taxes for the lower brackets and the lower incomes, etc., and help also the biggest corporates to green their production processes. That can happen at the national level, and then I also agree that at the international level, of course, there is a group of countries, like the advanced countries like mine, which have already filled up their quotum of, let's say, greenhouse gas emissions. Then there is another group of countries which has not done so in the past, but is now being told that it will face identical prices and identical costs because the climate is full and nothing additional can be issued there. Of course, that also sets the stage, I believe, for international solidarity and for some form of transfers also for the rich countries to the poorer economies. And by the way, Ignacio, you mentioned the word moral hazard. In other themes, I've not been shy of using that word, but here I'm not afraid at all that this is such a sort of central theme here. I think we suffer all from climate change, and therefore we just have to help each other and enable also each other to make the transition here. And to the extent that countries cannot do it themselves, well, then of course there needs to be international solidarity. which would probably then also strengthen the resolve of such countries to also do their part.
Okay, thank you very much, Klaas. I agree with that. Obviously, if you use properly the revenues from carbon taxes, clearly this would help. One would also hope that there would be no revenues from carbon taxes if really countries were able to move fast towards renewables and very low carbon emissions. So it is the standard proposition that we have on taxing markets. For example, Tobin tax worked the same way. Now, I would like to move to the third set of questions in our third round of questions in our discussion before concluding very quickly. And this has to do with the fact that in both the G20 and in the G7, we noted the increased focus of member countries on other environmental, non-climate related topics such as the risk of nature, biodiversity, degradation of the ecosystem, and so on and so on. There has been a Das Gupta report, there has been the OECD who has focused on that, and so on. And this is also what yesterday Professor Hill was mentioning in a very interesting talk. Now, my problem would be really to understand, given that biodiversity and ecosystem degradation are material economic risks, what are the tools that we need to put in place to monitor them? They are very little monitored. But on the other hand, there is really a pressing question about the fact that perhaps the growing focus on this topic may become a distraction that reduces the climate priority on the policy agenda. Is sequencing also here relevant or not? I don't know, Nick, whether you want to say something on this.
Let me start with a bigger picture, then come down to the specifics of biodiversity. We've been talking about a new growth model where investment takes different forms and a way of understanding growth in a broader sense of growth in living standards in a different way. And there, I think, if we think in terms of four forms of capital, physical, human, natural, and social, then I think we start to get a picture of the kinds of investments that we need. We've focused particularly on physical capital here, and that's a huge part of the energy transition. But the human capital, of course, is enormously important in this context, not just in terms of getting the job done of the transition, it does matter there, but also in terms of its contribution to well-being in a very direct sense. But the natural capital story is extremely important. And what we've done broadly as a world is increase our physical capital and our human capital over many decades, whilst at the same time we've been destroying natural capital. And that natural capital is in large measure infrastructure. If you think of infrastructure, the meaning of infrastructure is activities that facilitate investment in activities that facilitate other things that we do that have value. And then in that sense, natural capital is clearly, not all of it, but much of it, a form of infrastructure. In large measure, how we manage our land and our trees, we restore degraded land, shapes the way in which water flows, the whole water systems in a very profound way. If the Amazon collapses, it's a biodiversity disaster as well as a climatic disaster. So I think we should see this as part of a story and not, as it were, one against the other. A dangerous climate, as the Amazon example is a very clear one, a dangerous climate undermines the Amazon, and that undermines biodiversity, and they have feedback effects. So they're very, very closely related. The emissions of the carbon dioxide and other gases are responsible for the acidification and the warming of the ocean, which undermines the whole ocean side of biodiversity. So number one is that they're interrelated and similar policies will help. But the second is that it's not quite as simple as that. You know, overfishing, for example, is about property rights. It's about organization, incentive structures, and that's, you know, beyond the idea of in climate change. So we should recognize both the interweaving and that some activities to protect our biodiversity will not be the same as climate. I don't think in competition with it at all, but they would have to be additional. So I think that the biodiversity story is very important. It's not a diversion because of the extent of the overlap. It's not a diversion because of the importance of natural capital in rising living standards or protecting living standards around the world. And we ought to have the bandwidth and the understanding to manage both at the same time without setting one against the other.
Very well. I don't know whether someone else wants to join on this particular topic. We have about 15 minutes, so we may have a few minutes for this, and then I will ask a very quick question at the end. I don't know, Gita, do you want to say something on this issue?
I mean, to be clear, I mean, at the IMF, we are currently focused on the climate issues and related issues. So that's where I would say we are concentrated on. But I agree with Nick that, again, I'm no expert on this, but my sense is, especially when you're talking about preserving forests, that there are synergies between the two forms of activity. So, you know, hopefully those are the synergies that we should be exploiting. But I don't have anything more substantial to say on this.
Yes, thank you very much. I think we have been discussing since 25 years about sustainable development, and now everything has to be sustainable. Isn't there a risk in using too much this concept, Michael?
So sorry, the question is there a risk?
Is there a risk of using too much the concept of sustainability, and in which
yes. Okay. Yeah. So of course, Nick is right, and of course, Gita is right, that the natural environment is you could think of it as a capital stock for human well-being. And when you just start hearing the numbers of species loss and a variety of other measures, they're very troubling. I think, and this is, a terrible line for an academic to say, but I think this is an area where a lot more research is needed, which is probably something academics think about almost everything. But I think as we kind of move down and make progress on the climate problem, and there'll be great complementarities, no doubt. What's really important, I think what's very important is that we try to help people understand the trade-offs. And there's no getting around that there's going to be trade-offs in confronting the climate challenge or the global energy challenge. And I think having a sense of being able to better quantify what some of the value of the ecosystem services are, I think will make that an easier case to make to people. For instance, some very exciting research on the value of bats in the United States, the little animals that fly around and eat insects. But I think we need a lot more of that. And I think without that, there's a risk of appearing tone deaf to the people around the world who are desperate, and there are billions of them, who are desperate for more and less expensive energy.
Thank you very much. I think that we have substantial data gaps, and we have to fill them, and there is obviously a global effort which has to go through the international organizations, and each one of us is contributing. What do you think, Klaas, about that?
Yeah, I tend to agree with previous speakers that the relevance is clearly not less. If you look at these numbers of population sizes of wildlife, for instance, and the species that are threatened with extinction, etc. I also think that there are complementarities and interrelationships, but it is true that in terms of data and analytics, this is still a bit farther behind. And that's, for instance, one reason why also in the financial regulatory community within the FSB, we have decided that we ourselves first focus on climate-related financial risks, but that we welcome very much that the NGFS, the Network for Greening the Financial System, actually starts up also more work in the area of biodiversity loss. Then the NGFS is a little bit more a laboratory of sort of new ideas and new experiments, but then we hope, of course, in due time that also within the FSB we can take these risks on board. And as you correctly say, Ignacio, the key is, of course, to get data. And at least on climate, we have now a standardized set of disclosures on which we can sort of hopefully start measure or collect data and measure risks. There's still a lot of data, by the way, that also in the climate-related area that we need to gather. But that is something that needs to happen. A task force on nature-related financial disclosures, that is, I think, very much to be welcomed. Because the importance should clearly not be underestimated. Just one piece of data. We have asked actually the Dutch financial sector their exposures toward companies that are highly or very highly dependent on ecosystem services. And that was also a number like 510 billion euros only for the Netherlands. So these numbers are potentially also quite mind-boggling, I would say.
Thank you very much. As upcoming chair of the FSB, we count very much on you then. You have a lot of responsibility in trying to somehow give us some answers to these data gaps. But also on these, I'm encouraged by the interest that the private sector has shown in a discussion with the Sustainable Finance Working Group about the nature-related and biodiversity issues that may somehow, once they are properly disclosed in terms of the impact that corporates may have on the society, not only on the economy, may become better priced. So I think there is a lot of work to do, both on research, data, and also on policy. I would conclude, if you indulge me, with one final rapid-fire question, which is obviously the one that has to do with the COP26. It's only a few weeks away. What is the one thing you hope to see come out of the meeting to advance the role of finance, which is our own field, clearly in tackling climate change? Why don't we start from Michael, who has been joining late, and he may have some few minutes. Michael.
Yeah, I think the most important thing that I'll be looking for that comes out of finance comes from when you look at the projections of where emissions are expected to come from around the world for the rest of the century. And I don't have the right exact number in front of me, but I think, and I'm sure Nick will know this off the top of his head, I think 85% of emissions that are projected for the rest of the century are projected to come from today's developing countries. And the truth is, the trade-off looks very, very stark for them. If you just read the data and you look at their trends in emissions, and so I think what has to come is at least the beginnings of a concrete deal that will enlist the today's developing countries in doing something to reduce their emissions. And I think they have been trying to avoid that for several COPs, and I understand their perspective. I understand why that's true. And at the end of the day, someone has to pay. And I think the developed countries, the rich countries, should find a way to induce real participation from today's developing countries. Otherwise, the trends are the trends, and I think we're looking at continued future growth in emissions around the planet.
Yes, Gita, what is your point here?
I think Michael hit the nail on the head on the biggest point. I would add I may, more than one, but just quickly, a couple, which is one, delivering on the 100 billion uh, uh, goal for financing on an annual basis. I think that would be one important piece. Second is, of course, that's not going to be enough, because to get more financing for the kinds of investments that are needed, the scale of investment that's needed, you just need much better harmonization of data, standards, and common frameworks on that, and also for incorporating climate-related risks into stress testings and financial disclosures. So those would be my broad set of additional targets.
Class?
Yeah, there's a lot, of course, to desire for, because it's such a multi-pronged challenge that we are facing. But if you want me to be very concretely, I hope, of course, that a broad international agreement can be reached on mandatory disclosure of climate-related information. We've been working on it very hard. Let's hope that at COP26 we can hammer this one home, an agreement within which also the role of the IFRS, International Sustainability Standards Board, will be recognized, so that one can really be going and rolling. And other than that, if you allow me a small second one, reaffirmation of the importance of carbon pricing, because I'm a little bit concerned with what the current surge in energy pricing is doing to the sort of the willingness of our politicians to spend political capital on carbon pricing. So if we could get a sort of reconfirmation of that importance, that would be my second one. And then I violated my my time here. So thank you for indulging me here.
I'm giving the last word to Nick Stern, who started this debate a few years ago, and maybe tell us what he now expects from COP26.
Expect and hope are different things, but the I'm with Klaas and Geeta on the importance of transparency, and with all of us on the importance of carbon pricing. But one thing I would emphasize, same as Michael, and Michael, it's lovely to hear you, if not see you, is low-cost finance on the scale that's necessary. And that 100 billion, I negotiated the 100 billion back in 2009 when I was working with Meles Zenawi, who was speaking for Africa, and Mike Froman, who was working for Hillary Clinton. So it's in my bones, as it were. But it's, as Geeta emphasized, it's a small part of the story. We have to deliver it from the point of view of trust. A word was given, a word has to be delivered. But we'll probably do that in 2022 or 2023. We're crawling over the numbers now. But the bigger story is financing those trillions of investment through low-cost finance. We don't want to replace the 100 billion with some other aggregate. We're going to need a lot more bilateral. I would argue tripling by 2025. A lot more multilateral. It's crucial that the MDBs expand their ability to lend, and the shareholders stand behind them. If that's used in the right way, the private sector multipliers could be much bigger than now, with much stronger focus on the management, sharing, reducing of risk. And fourth dimension would be voluntary carbon markets. They could be really pretty high now. And Michael rightly emphasized the voluntary part of the story that many people and firms want to cut and pay for the cutting of emissions. Those voluntary carbon markets could be very substantial, and I hope that we'll make progress on that. So the story will be to look at the numbers. Geeta gave them, I gave them, we're roughly in the same ballpark, and look now at the specifics of how to finance it in nature and in scale. And I think we can do that, and I'm hoping for a step forward at COP26 on exactly that.
Well, thank you very much. Thank you, Geeta. Thank you, Michael. Thank you, Klaas. Thank you, Nick. This has been really an excellent conversation, very interesting. And really the issue that at the end Nick pointed out about trust, I think is crucial. We need to build trust. We had this pandemic that made even physical meetings very difficult. We are starting to meet again in presence, and is extremely fruitful. We have a difficulty with China. We hope really that China opens again and even physically, and so we can meet and really start discussing these things at length. It's not easy. I think politicians, the willing politicians, have to act. I'm counting on Mario on this, as he has now the presidency of the G20 that will meet at the end of the month, but obviously COP26 will be crucial, and the British are really to play a major role there. So thank you very much, all of you, all the participants here in person in Milan, and all of those who are connected remotely, for this very fruitful exchange of views we have had today. And I'm glad now to conclude today's discussion saying a few words concluding the conference. A few remarks, I just put them down now. We are at the end of this conference, which has been interesting, and I'd like first to thank all the speakers, the chairs, who gave us important insights on the economic implications of climate change in these 2 days, and on the transition specifically to a net zero world. I would also like to thank the colleagues of our staff, both here and in Rome, where this has been organized, the help from the Bank of England side, the Milan branch, who have made the organization of this event possible. The remarks I'd like to make are very few. The main takeaways of the conference, which I see, are the following ones. We had plenty of evidence that climate change poses both physical and transition risk, with impacts on the economy and the financial markets which are substantial. And also, I would emphasize this non-linear. The non-linear part of that is crucial. This has come out in the discussion. There is a need for more and better information. And this has also been a topic which has been emphasized in the panel, as well as an enhanced research effort to develop analytical tools to integrate climate change scenarios, the NGFS ones, for example, that have been mentioned, with the macroeconomic modeling, the analysis, as well as financial modeling. And the financial modeling that was emphasized by Monica Pelzesi is interesting. We will consider that in our monetary policy discussion, even if some of us may not feel being so extreme in what has been put forward. The important thing is that all this is useful and I would say essential, indispensable instrument for assessing the economic, the social and the environmental costs of not acting. The second point which I take is that the academics have showed us that while technological innovation is key to achieve a net zero economy, policies and incentives for the private sector to innovate are still largely insufficient. There is more financing needed. It has to come from the public sector. 1/3 is what Gita mentioned. The other 2/3 we have to come up with ways of having the private sector really being convinced that this is absolutely necessary. And indeed, estimates suggest that green innovation has been somewhat declining in recent years. So we need investment. Optimal climate policy requires both carbon pricing and public incentives for innovation. There has been, as I was mentioning, some research that suggests that monetary policy interventions might unintentionally benefit high carbon activities, reducing the relative cost of capital. However, how monetary operations could help to tackle climate change is still a debated issue. What is sure is the importance for central banks of integrating the impact of climate change in our financial and economic analysis. From the conference sessions as well as from the discussion in the panel, I think a main unitary view on the urgency to act to combat climate change has emerged. We have learned that climate change is seriously damaging our economies and that its effects will increase in the next few years. They will increase dramatically indeed if temperatures overshoot the 2%, the 1 to 2% Celsius thresholds. On the other hand, we understand very well by now that decarbonization has net benefits. It is a complex process, one that requires policy clarity and finance to help accelerate the transformation towards carbon neutrality, but one that we absolutely have to pursue. And it is clearly a particularly challenging process, as Gita and also Nick have mentioned, in low and middle income economies. The 100 billion is there to be used. It has to be used. Moral hazard is a minor issue here. We really have to make a major effort. And as Nick said, then I think the economies of scale will be there, and therefore there will be a probably virtuous circle rather than going back to a more conservative view. The challenge indeed is really global. It follows that international cooperation, under many respects coordination, are absolutely necessary. And this is why so much attention and time are devoted to this issue, and why we look with high expectations and, as been mentioned, some trepidation to the upcoming COP26 conference in Glasgow. Well, I indeed hope that this event has contributed to inform a more effective global coordinated action. I wish again to thank you all and say you all arrivederci. Bye-bye then. Thank you. Bye.
Arrivederci e grazie.
Bye-bye then. Ciao.
Well, thank you very much. This is the end, and thank you for being in Milan. I hope that it has been a pleasant experience, and to see you again soon here at the Milan regional branch for going on to discuss, to provide good research and new research. Thank you very much, and thank you to all of the people who have contributed to make this conference, I hope, a success. Thank you very much.
Grazie.